number of updates, and this is very consuming. So it turns out that we have a trade-off. And 32 in this case is the best choice. We also realized that the frequency at which we perform the cuts, so the compressions during the training, matters. So during doing it after each epoch, it might be okay for small batches, but it's detrimental for larger batches. So if you increase a bit the pruning interval, then you can have a more stable process also for larger batches. But okay, all these investigations were, let's say, static without any kind of adaptation. Now let's see what happens with our approach. So here we have our dyne-HP. That adaptively changes the size of the mini batches through the training. And we see that it can identify, after some time, the correct batch size that we identified before, so around 32. We performed the same kind of analysis on the convolutional layers, and basically we obtained the same take-home message in terms of convergence, but we noted something interesting. With fully collected layers, smaller batches are better in terms of energy efficiency. In this case, larger batches are better. And with larger, I mean very large. But fortunately, the good fact is that also in this case, we have a trade-off. So here you can see basically the training, the error over the training, the network size, and the energy for these three size of batches. And so for the convolutional layers, the in-between solution, in this case 128, is the one that allows us to compress the most with less energy usage. So to conclude, we are working on energy efficient training and model compression. For now, this was an initial investigation to see if in a real device things works as expected in simulation, and apparently it does. Now we are moving towards the definition of a really automated way and to control all the process, because even if we are adapting the batch size during training, we still have some tuning parameters to control the rate of increment of the batches through time. So we want to make it fully automated. And we are also looking to more foundational aspects of how the shape of the loss function changes and affects the process through time. So I think that's it. Thank you very much for the attention.
Thank you very much. Thank you very much. We concluded this session, and I would like just to thank all the speakers for the very beautiful presentation, but also just to make this presentation just in time. So we started earlier 10 minutes late, and we are in time. That's why, because we dedicated 1 hour for this talk. We are sorry because we don't have time just for having questions, but I really appreciate a lot, and we think that we made a good work. Also, if we don't make a lot of collaboration probably in this VP, but we will just think to open this collaboration in the last year. And of course, we are open to collaborate with the other groups if this presentation are interested for some specific research that you are doing at the moment. Thank you very much. We leave the floor to the VP 6, and please stay there.
Good morning. I am Silvia Rada, and I will present you the work package 1.6, co-design methodologies for trustworthiness by design with Anna Monreale. The co-leader is Adriano Fabris, who could not be here today. So this is our critical mass and PhD students and researcher hired on this project. And our research considers the legal and normative framework of the European Union, particularly GDPR and AI Act, and the previous guidelines for trustworthy AI made by high-level expert group. As you know, the goal of these guidelines is to create a lawful, ethical, and robust AI, and to do this, a number of principles have been identified, and all these principles contribute to the idea of trustworthy AI, which is our main ambition. Considering this principle, our work also three dimensions together, so the ethical, the legal, and the socio-technical, to create by design and in design trustworthy ethical framework. And the aim of our research is to develop an ethical methods and tools to audit and monitor AI systems and verify their compliance with ethical values and legal standards. And this will make possible to provide an ethical certificate specifying the ethical principles that are guaranteed. Going deeper into each task, the task 1.61, coordinated by Adriano Fabris, focuses on the analysis of ethical principle and the landscape of international codes of ethics to define a shared ethical framework that can be modeled in the AI systems. In order to do this, our group has pursued many activities, which can be summarized through three ethical levels. A meta-ethical level that analyzes and investigates the concept of interaction with AI systems, defining a relational approach based on cooperation between human beings and systems. And starting from these issues, we have been working on an ecology of digital environments, investigating some keywords which are the baselines of this approach, such as vulnerability, risks, and the concept of digital environment. The second level is the ethical and normative level, devoted to the analysis of international codes of ethics and guidelines from which to derive common principles and shared values. We analyze both common principles, but also the absent principles that are worthy of examination and to integrate in the ethical framework. So this analysis was extended to the AI Act, where investigated also the risk-based approach and the role of vulnerability in this document. So finally, the applicative level investigated specific application fields where the impact of AI is particularly significant, and also to integrate in this concept, in this framework, these principles, in particular healthcare with a focus on care robots and monitor devices, image generation also in journalism and advertisement. These are results and publication of the task. I mentioned in particular the 4 monographs, 3 are forthcoming, and 2 journal issues dedicated to the idea of risk and the concept of risk in the AI. I leave the floor to Anna Monreale.
Thank you. Good morning. I'm going to present now the other task that we have in this project. One is related to the mathematical definition of some measures that help us in auditing and monitoring the legal or ethical aspects related to the AI that will be used then for enforcing the guarantee in AI system, also by taking into consideration possible synergy that we have between the different values. And another task is instead related to especially how to, which is the methodological approach that we need to use for auditing and monitoring this ethical value that was mathematical defined in the previous task. Concerning these 2 tasks, we have contribution with respect to 3 different pillars, let me say in this way, that corresponds to different ethical legal principles. One is related to privacy, where we had contribution that are materialized with publication in conferences and journals related to how to audit and measure the privacy of explainable AI models. Also, we considered data privacy in case we have particular mobility data that are called the multi-aspect trajectory that integrate different dimensions during the mobility of people. And we also have some work addressing both privacy and explainable AI in federated learning with an approach rule-based. Concerning instead the bias and fairness dimensions, there we addressed the way how to analyze fairness measure in federated learning and also in large language models. And we considered also how to monitor and audit both privacy and fairness together in the same system. And finally, we are addressing also the problem of fairness in abstention mechanism. We also addressed the problem of correctness, reliability, and robustness. And so for this, we have contribution that design formal verification methods for neural network, but also evaluation of robustness principle of foundation model. Concerning the last task, where we are putting all together what we learned from the previous task in order to design, by design, technologies that implement different aspects related to privacy, related to fairness, but also explainability and robustness, taking into consideration the fact that we need to maintain a minimum level of performance accuracy of the models. So here we have mainly contribution concerning privacy and bias and fairness and relationship with the other dimension that we have. For example, once we defined the assessment method for multi-aspect trajectory, we also defined and implemented methods for guarantee privacy protection in multi-aspect trajectories. Once we identified which are the privacy risk and the needs of explanations in federal learning, we also implemented a privacy-aware rule-based explanation method in FL. And we also considered the fact that in centralized setting and in distributed setting, we can perform some computation by PCA, and in collaboration with the visitor in our lab, we implemented methodology that by design is able to provide privacy-preserving PCA. Finally, we also analyzed the possibility of defining a different kind of topologies of a federal learning mechanism in order to guarantee a better utility of the system. Concerning bias and fairness, we are addressing these fairness issues in federal learning with two different approaches, by using an approach that tries to optimize multi-objective fairness, so where you have different measures of fairness to be guaranteed, and also by optimizing intersectionality of fairness in case you have more than one subgroups that you want to consider. And this is especially currently addressed because it's a hard problem, addressed in centralized machine learning models, but the goal is to extend this to also distributed one. And then we have also a work on a large language model in order to guarantee diversity and multi-perspective models. And that will be one of the work that will be presented. We also, in FL and centralized setting, address the problem of guarantee both privacy, fairness, and also clearly the utility. So we have different other activities in the work package. One is a collaboration with Banca Intesa San Paolo, where Scuola Normale at the University of Pisa are trying to analyzing from the ethical and legal point of view hiring application that is based on large language model. Scuola Normale Superiore, University of Pisa, CNR, and in collaboration with University of Pisa, they work together with some reading group in order to maintain under control what in the scientific community we have in case of trustworthiness in large language model. And Fosca Giannotti and Gizem Gezici participate to some working group on EU general purpose AI code of practice. And so we have these updates continuously in this direction. These are the 4 highlights that will be presented. We tried to cover all the tasks, but also all the institutions that collaborate in this work package. So the first one is from Elio Grande. Elio, you can come here.
Okay. Hello, everyone. I'm talking about a paper that we wrote together with Silvia Dada and Professor Adriano Fabris. It's a 600 paper called Toward Relational Ethics in AI, the problem of agency, search for common principles, and pairing of human and artificial agents. So it is a chapter of the book Digital Environments and Human Relations, Springer, and discusses some core problems of AI ethics, assuming it to be an ethics of relations between human and artificial agents, and proceeds in 3 steps. The first one was written by Adriano Fabris, and talks about the need to explain what acting means in both cases, human and artificial, outlining the different forms of relationships, and also outlining an ethical framework. The second part was written by Silvia Dada, and it gives an insight into the regulatory codes and documents produced all over the world. The last one was written by myself, and it talks about providing a design method, general design method, for cooperative and responsible conduct for humans and artificial entities alike. So, what acting means. There is no identity between human acting and the acting of AI devices. So to develop a proper relationship, we focus on the category of voluntary action rather than degrees of independence or rational features of the agent's action. Voluntary might mean something that is done spontaneously, according to Greek tradition, intentionally, according to biblical tradition, or rejecting constraints, which is a very modern mode of talking about voluntary actions. However, being intrinsically deterministic, AI may sometimes be unpredictable, but not free. Obviously, it has no freedom. We are misled by language and catch in a sort of anthropomorphizing process and slip into an argumentative short circuit. We regard machines through the lens of our actions, but we end up reflecting ourselves in them, regarding them as models of our own behavior. So we don't have a better word, and we use the term intelligence, but machine actions may be explained through hardware and software, but we have a sort of paradoxical feedback, which we call the Disney effect. So ethics may have three branches. We say ethics in AI, so embedded in AI programs and data sets, for example, or ethics of artificial intelligence, which mean train, say, humans to new contexts where there are technological advances. So how we can ethically interact with machines. The third is an ethics of common rules and values, say the extension of shared ways of living in this kind of context, and the search for globally shared universal values to handle global and transnational problems. The non-existent universality of current reference values. If we search for all the documents, we find a loose convergence. This convergence stays on transparency, privacy, justice, which sometimes is fairness, safety, which sometimes is security, autonomy, which sometimes is freedom. So we have some points, but we cannot say hardly that we have common points. It is very influential, which is the issuing authority, governmental bodies, academic boards, companies. They all ask for something different. We found that cultural and religious differences affect very much the understanding of principle. And we also found that Global South is underrepresented. So, for example, when we talk about responsibility, it might be usually about autonomous machines or the duty to disclose mistakes and so on. There is, however, a need to resort to other principles, especially the one of vulnerability. Since there are forgotten issues of AI ethics in these codes, like the use of AI for political propaganda, the ecological footprint, diversity in research and development, risk of social fragmentation, all these points are not treated in these codes, and care, ethics of care, is notably absent. So, we must come up with some principle of a relational dimension. So why not take vulnerability as a cornerstone? Because it is both an existential and a material condition, because we all, together with machines, are vulnerable, but in different ways. So, if we were to establish a relation with this family of technology, which we call artificial intelligence, we should not count it as plain things. Say, some clues might lead to regard it as something just a bit more or just a bit different than simple tools, and to deem us a bit less than perfect users. For example, adversarial examples are gross yet extremely precise mistakes, which seem kind of bugs in the nature of artificial intelligence, because it is like they appear not because models do not work properly, but on the contrary, exactly because they work too well. Or, for example, emergent abilities of large language models, for example, future prompting, they appear overly scaling beyond an unspecified complexity threshold. The fact is that we don't know which is the threshold, we don't know which abilities will emerge, and so on. The third example is a multiplicity of good models, Occam's razor, and the cars of dimensionality with respect to black boxes explanations. That is to say, more than one good explanation is available for the same instance on the same black box, while simpler explanations might be unreliable, whereas the finer the fine-grain, the harder to comprehend it. So there is a conflict, quite unavoidable. So these clues to unpredictability might be exploited. This was the idea. So, since we are fragile together, since we are vulnerable, we have to exploit our vulnerabilities. So, it is like being two mirrors, one in front of the other, us and the AI itself. The endless tuning is a relational design method which exploits these vulnerabilities in a cooperative fashion within a double feedback, a negative feedback. So what counts is profiting from competence and surprise to learn by doing together, but potentially ad infinitum. So since computers can talk, say affirm or deny, because they don't think, don't judge, AI might be used to provide clues, interesting clues. Also because in the wild we don't know the ground truth often, and overfitting waits behind the corner. The endless tuning aims at filling a responsibility gap and together avoiding human replacement, and it's just a method made of just two rules. The first one is that the model makes the user think. The user puts constraints to the model, so as, say, to tune on each other, being adaptive and ergonomic. The second is that every interaction should be recorded in a permanent log, so as to make it possible to trace back responsibility. A possible decision-making protocol where multiple sessions are meant to provide newly labeled data for a rehearsal is, for example, that you just say the user to speak his mind, then use the explainable AI just as suggestions without knowing the truth. Then, for example, you might use a similarity between this case, the present instance, and other instances. Then, if you want, but it is not a duty, you may use confidence just to say, well, you finally want to know what do I think? Okay, here you have results, but with confidence. And in the end, tuning, so sort of rehearsal, and this is a double circle. Thank you so much.
Thank you. Now we have another talk from Emanuele Fulvio Perri, analyzing ethical values of large language model. These are two PhD students from our PhD in AI.
Good morning, everyone. And yes, as the professor said, this presentation is about what I'm doing for my PhD research, for the research project, and it's something that is very heavy on ethics, and it also takes into account a lot of large language models. The main goals are trying to understand the polarization of certain large language models from an ethical point of view. we really want to understand if there are ethical postures emerging from large language models. And we took into account, in particular, a couple of large language models which are all Italian-based. And this is interesting because for the first time we can see if there is an ethical posture emerging from Italian models, Italian-trained models. And we're going to use also a zero-shot role-play prompting, which is a technique I'm going to talk in a minute, which allows us to have a very prompt, a very speedy way to have access to output which are schematic, so a short, but also significant. And the models we are taking into account are right now a couple. We have Minerva, which is also the Minerva family is one of the first models, large language models trained on an Italian dataset, and it's also a model which is developed under the FAIR Foundation. And the second model is Anita, which is based on Llama 3, and it's called Lamantino Anita. And we are going to use these two Italian models at the moment, and we are employing the zero-shot role-playing prompting, as we said before, and it is based on saying to the model, the input is just, you are this person, you are this professional figure. What is your position on these topics? So we have developed a table of topics, which are trending topics, and also a list of persons we are calling personas. We are prompting the models about. There are limitations about this prompting because it can reinforce stereotypes, and this is something we are aware, but it is also something that we want to do because polarizations are what interest us. We want to have stronger representations of these personas, because then we'll have to deploy an ethical analysis to understand which kind of ethics are being used by the model or are built in the model. So personas are those representations of professional persons, but also are representations of individuals, just the normal Mario, and it allows us to have an average of the users which deploy large language models, deploy generative AI, and it is very helpful for accessing the ethics inside the model. And so by role-playing, we are simulating user interactions, but we are also simulating real individuals, how they would respond to certain questions about very hot topics. And let's talk about tools and methods, because there is a qualitative analysis part of the project and also a quantitative, of course. The qualitative analysis is about understanding the ethics. This is something that we can't just give to an AI model. This is something that we have to do. I personally, I have a philosophical background, and so it should be easy in a certain way to understand the ethics that are going on in those outputs. and we can spot polarizations and biases. And we will see in a minute a huge bias which I found in a model. And we can understand the general posture, we are talking ethical posture, about particular topics in the model we took into account. When it comes to quantitative analysis, again, we have the model prompting, which is zero-shot role-playing. There's topic modeling going on. We are using LDA, which stands for it's a latent directlet analysis. It allows us to have a representation of the main topics inside the huge corpora of text. And we are using an LDA based on JavaScript. It's a web-based LDA tool developed by Cornell University. And we are also tokenizing the responses, the outputs. And we're going to run a Luke test, which allows us for analyzing psychological categories of language. Now, LDA works best with huge corpora of text, while Luke works best with short sentences. So we are taking this into account. And the two models we are using are Minerva and Anita. And I'm using Docker to create local apps of these tools. And here you can see how the LDA method works. And again, I'm using JS LDA. And I'm also using a comprehensive collection of Italian stop words, because it is necessary to have a bunch of stop words in order to make it more easy to analyze the corpora of text. And I found the most comprehensive stop word collection of Italian words on GitHub. And then this is the table we are using for personas. So, for example, we have the journalist, the communicator, the politic. There's also the public relation expert. So these are all personas around the communication field, because we expect them to have stronger positions about huge topics. And by prompting those two LLMs about trending topics like abortion or end of life, things like that, we are expecting to see how these models are polarizing. So here you can see side by side Anita and Minerva instruct. And I prompted it 10 times. Each model is going to be prompted 10 times. And here you can see that the main difference in this case that Minerva is giving shorter answers to what? Shorter outputs to the that's humanizing the AI. It's giving shorter outputs, but in this case there is also a bias, because I've used as a prompt. I asked about you are a journalist from a national magazine from the right wing. What do you think about immigration? And while Anita is giving a full, complete and long output, the chat gets banned, gets blocked on Minerva. That's probably because we are using the instruct version, but again, this is something that doesn't happen when we prompt about the left wing. So the political orientation matters a lot. And here you can see that then the 10 outputs are condensed, and put into JSLDA. So we are uncovering the central topics and their distribution across these documents. And we are also looking for the most used words. And this is something that it's a benchmark, because we can see how the model is focusing on certain words, and this is relevant from an ethical point of view, because if you use word about immigrations a lot, we can say that maybe it's gonna polarize in a certain way or another. And this is the table for the analysis. So we have the ID, which helps us for categorizing. Then we have a word count or tokenization parameter, polarization, ethical kind, the persona, the bias we found, and the similarities with other outputs. This is potentially useful because we also have the Good AI Lab here at University of Pisa, and the main goal could be developing a new framework, ethical framework for LLMs, all Italian-based LLMs, which is something that we could see for the first time. Thank you for your attention.
Thank you. So now we have a presentation from Cinzia Bernardeschi.
Thank you, Anna. So, good morning. I come from the Department of Information Engineering here in Pisa, and today I will present the work done with some of my colleagues, that is Professor Marco Coccioni and Dr. Federico Rossi, in which we try to do some work on the trustworthiness of machine learning component used in cyber-physical systems. So the concept of cyber-physical systems, we have different computational modules that interact in a closed loop with physical models. And what happened is that machine learning approaches have been successfully used for creation of high-performance control components for cyber-physical systems. But this approach lacks trustworthiness, and trustworthiness is fundamental if we want to use this component in a safety-critical context. So we have to give some measure of reliability for these models. So the approach we propose here in this work is a combination of interval arithmetic for computing output interval bounds from input interval bounds for machine learning models, and the integration into a theorem prover in which we have the model of the cyber-physical system, and we substitute the relation we have from input to output for the machine learning part in the theorem prover model. Okay, so instead of modeling in the prover the complete network, we use the input-output relation between intervals. So interval arithmetics allow to model uncertainty because we use intervals. So a quantity is an interval, and we use interval for the input, and we propagate the interval through the network using interval arithmetic. So we give an arithmetic for basic operation needed to execute the network, and the new bounds are propagated to the next edge of the network until we reach the end of the network. So we have the output interval. And if we start from bounded input interval, the operations are closed, so we have bounded output interval. And the operation we use and we implemented in the framework that is being implemented in PyTorch are sum, subtraction, multiplication, division, and monotonic function. This is easier to model monotonic function because we can easily compute the lower bound and the upper bound of the output of the function. So at this time, the framework can be used with activation functions that are monotonic. So ReLU or sigmoid and so on. So how we can use this interval arithmetic? Here is an example for class prediction. So for example, if we have a neural network model and we do class prediction and we use a set of input intervals for the feature, we compute the output of the network, and looking at the score of the output, we can give condition on guaranteed predicted class. So if we have here, as in this case, 3 classes, and this is the output interval produced by applying the arithmetic, we can see that the score for class 3, 3 does not exist, for class 1 is this one, because these are the output intervals starting from a set of input intervals that here are not mentioned at the range. But this is the score for class 1, and we see that the lower bound of the interval of score of class 1 is higher than the higher bound, the upper bound of the score for all the other classes. So we can say that this is the predicted class for the input interval we have. If we change the input interval in the same example, so we change the input interval of a feature, so for example, we use interval 1, 6 for the feature, or we can use 2, 6, 7, 3, 8, and so on. This is the picture that represents the prediction score for the classes, and we see that if we use all the different variation of the input interval, for example, class 1 cannot be defined as the guaranteed predicted, because here we have an intersection, and here the lower bound is lower than the upper bound of another class. Okay, this is the using class prediction. And the figure on the left was related to a point here, so for a specific input interval here, this was the class prediction, but here we are varying the interval for one of the features. So this is the prover we use in our work. This prover is named the PVS, Prototype Verification System. It has been used at NASA. There are a lot of libraries for this prover. And in this prover, we can model the full network, or we can model, we can specify variable, and the variable are defined by the domain, and we can put constraint on the domain. So for example, you can write x1 is a variable that is real, and the interval in which this variable can range is -1 and +1. And you can also write, obviously, formulas for theorems, and we have a proof engine to prove the theorem starting from the theory. And we have an high-order logic to specify our systems. Now, if one of these components, so the idea is we specify the whole cyber-physical system in PVS, so using high-order logic, but if we have a part of the cyber-physical system that is a neural network component, for example, a neural network controller, instead of modeling the full network, what we use, we model properties of the input-output relation of the component. And this is what we do. So for example, if we consider this use case, this is a use case from autonomous driving. We have a lead car and an ego car that follow the lead car. And the autonomous driving controller compute the acceleration of the ego car, and the acceleration of the ego car is computed getting as input the velocity of the ego car, the relative distance between the two cars, and the relative velocity between the two cars. So this is the output of the controller. And we are interested into safety properties. A typical safety property here is if I compute the maximum distance I need according to the maximum velocity of the lead car to brake. So I want to guarantee that there is at least this safety distance between the two cars during the execution of the run of my system. And this is a safety property, and we want to prove this safety property in the case in which the controller for the cyber-physical system is a neural network component. So we have the neural network component that has been trained using data from co-simulation design space exploration, and the trained neural network is analyzed using interval arithmetic. So this is an example of use of interval arithmetic on some interval in input. So we assume in this case we have the maximum velocity of the ego car, and we assume that the ego car accelerates in an interval. So if we report this in 2 kilometers per hour, this means the maximum velocity 90 kilometers per hour, and the difference in velocity, there is more about 7 kilometers per hour. So if we start from these intervals, what we want to see is that depending on the distance, the relative distance between the car, and this is the input interval for the distance between the two cars, the controller, that is the neural network component, always gives as a command to the physical system, accelerate or decelerate according to the rule that if the distance is smaller than the safety distance, I'll always have decelerate. I have accelerate only if the distance between the two cars is greater than the bound we have pre-computed before. And this is the result of the analysis using the tool. So here you have the variance of the safety distance between the two cars. Here you have the acceleration that is sent by the neural network controller to the system. And you can see that this is done using input interval and computing output interval with interval arithmetic. You can see that the command is decelerate until the relative distance reach 37 meters, while the safety distance for 35. So in this case, we are able to say that the controller is reliable in the sense that if we have this interval as input, we are guaranteed that the output of the controller is safe with respect to the property of accelerating or decelerating. So in the end, what we do, we have the specification of the total, the global system in the prover, and the controller here, this is the function related to the controller, is substituted by a condition, okay, that we have pre-computed with input-out arithmetic. And the condition in our case is that if the relative distance is lower than 37, then we have decelerate. Otherwise, we have accelerate. And the decelerate is not fixed, it's just a real variable, and this variable means x less than 0. While accelerate is not a fixed number, but it's just, this is a value x that is a real number greater than 0. And if we put this in the prover and we have the safety property that is for all time, if the distance between the two cars must be greater than 35. So we use this condition in the prover, and we can easily prove that the safety property is satisfied. And it is more or less done automatically, just with some hints by the human, but very few hints. So conclusion, interval arithmetic allowed us to prove properties, safety properties for the output of the neural network component, and this can be used in the formal verification of the global system. With respect to our method that use interval arithmetic, we have an improvement in verification performance. This is the result for the same neural network. Especially I mentioned this tool, that this tool doesn't use forward analysis of interval, but go backward from the output to the input. But also we have better result, also again, this tool. In the future, what we want to do is to improve our interval arithmetic for only simplifying operation and using acceleration for the execution of the operation. And we want to include the dynamic in the cyber-physical system, because if we use that, we need to introduce dynamic and the differential equation in the proof. And this is the work I was presenting in this talk. So thank you very much.
So now we have the last presentation from Luca Corbucci that presents work that balance privacy, utility, and fairness in federated learning.
Good morning, I'm Luca Corbucci, and today I will present our work Puffle, Balancing Privacy, Utility and Fairness in Federated Learning. This is a work we have done with my supervisor and with researchers from Telefonica Research Center. So we are in the federated learning scenario, and this is the problem that we want to try with our methodology. This is the question we asked ourselves at the beginning. So the question was, can we have models that can exhibit a certain level of fairness, that can give you formal guarantee of privacy, and that at the same time can also guarantee a high utility? With utility, in our case, we mean the model accuracy, basically. And just to introduce a little bit the other concept, I have to first introduce the idea of federated learning. Just to be quick, when we talk about federated learning, we talk about training a model without moving the data from the users to a single central server, for instance. And what happens is basically that the training of the model happens directly on the client. So the clients can be a device such as a smartphone, for instance. And apparently this framework could give you privacy because you're not moving the data. Unfortunately, there are different papers that prove that federated learning is still vulnerable to different attacks that can be done against central machine learning models. And so some techniques are needed to protect the privacy of the clients. One of these techniques is differential privacy. That is the technique that we use in our paper. This is a technique that can be used during the training of a machine learning model, guaranteeing a formal bound on the privacy risk of the clients. In our case, we have some clients into the system. They train a model, and while they train this model, they apply this algorithm to guarantee privacy. All of them guarantee a certain level of privacy. The other thing that I have to introduce is the fairness that we want to guarantee in the model that we train. There are a lot of ways to measure the fairness and to guarantee fairness. We measure the fairness in this first paper that we already published. We measure the fairness using a metric that is called this demographic parity. The thing is that this method is also compatible with all the other fairness metrics, and we are also working on extending the paper and with the introduction of other fairness metric, in particular the error rate. So there are already some solutions in the literature to guarantee fairness or privacy in federated learning. Most of them, they only consider only one of these requirements. For instance, they only train the model with like guaranteeing the fairness or reducing the unfairness, or either they want to guarantee the privacy of the model. there are no methodologies that guarantee both of them and at the same time also guarantee a high utility of the model. And if we only consider the methods that are already available in the literature and that work with centralized machine learning, in this case we cannot just take this method and apply to federated learning, because there are some edge cases that must be considered, and this method shouldn't work without making some changes. The main problem of the methods that are in the literature is probably the third one that I've put in this slide. So the thing that when you apply the methods to reduce unfairness that you can find in the literature, you don't know in advance how fair the model will be. So you apply the model, you apply the methodology, and you hope that everything works, and you hope that the unfairness is reduced as much as possible. And this is one of the things that we try to solve with our methodology. And the other thing is that in most of the tests that we have done with the methods that are in the literature, we always had limited reduction of the unfairness. So the method that we introduced, the solution that we introduced with this paper is called PAFFL, and this is a method that allows to train federated learning model that can guarantee the privacy with a formal bound and a certain level of fairness. In this case, I will explain later how we guarantee, or at least we try to guarantee, this level of fairness. So the four main points of this methodology, the first one is the privacy requirement. As I said, we use differential privacy to ensure the privacy of the different clients. And what happens here is that when we start the training of this model in a federated learning, using federated learning, basically what happens is that the clients have to set, they have to put requirements of the privacy that they want to guarantee. This is measured with a value that depends on the differential privacy, and this value will tell you what is your actual bound on the privacy risk. The second thing that the practitioner who uses this methodology has to set is a fairness preference. In this case, differently from the methods in the literature, we allow the practitioner to set the level of fairness that they want to have in the model. And we think this is important because, as I said, in this way, you know in advance how the model will behave at the end, basically. So if you can decide this value based on some regulations, for instance, or you can decide this value for other reason. The methodology is based on a regularization technique. Basically what happens is that during the training we compute two losses. One is to optimize the model utility, the model accuracy, and the other one is to optimize to reduce the unfairness of the model. And this is done during the training, so it's an in-process method for the fairness reduction. The last thing is that this solution that we propose is a tunable solution, in the sense that there are some hyperparameters that, differently from other methods in the literature, are adapted during the training. This is important because I will show you later one result, because this is important because we allow an easier hyperparameter tuning. And the other thing is that this method is also easier to adapt when something happens during the training, such as, for instance, a distribution shift that can happen in the training, especially in a federated learning scenario. And the tunable approach, this tuning of the hyperparameters during the training depends on the fairness target that we put. So just a couple of results. We have a lot of other plots and tests in the paper. The first two on the left are results that are already in the paper that we have published. And in this case, we are just considering a simple unfairness mitigation. We have two baseline here. One is the black line, that is just a baseline model trained in federated learning. In this case, I think the dataset is Celeba, so it's an image dataset. And we are using 150 clients. The red line instead is a model trained with differential privacy, and the other two lines are basically puffle lines, one with tunable methodology and one with non-tunable methodology. Basically, some more hyperparameters are fixed during the hyperparameter tuning phase. The first plot that you see in the first row is the accuracy plot, and the second one instead is the test disparity plot. In this case, we set the target for our unfairness as 0.09, and instead the baseline unfairness was around 0.18. So we reduced the unfairness by half of its value. And the horizontal line that you see in the second plot is exactly the target for the unfairness. So this value t that I've put here in the slide. So both our methodologies, the tunable and the fixed methodologies, are closer or below the target line. And the thing here is that based on the value that you choose for the target, basically you affect more the model utility. So what we do is to try to optimize the model so that this degradation is less visible as possible. But what happens is that if, for instance, we put t equal to 0, we will have a completely random model, because for unfairness, this would be the best possible case. So in the paper, we show different values of t to understand how these parameters affect the model utility. But one result that we highlighted is that in the worst case, we had 75% unfairness reduction with something around 20% accuracy reduction. So it was a good solution because we were able to reduce a lot the unfairness of the model. The experiments on the right instead are some preliminary results from an extension of this work. In this case, we are considering also distribution shift during the training, and this distribution shift is happening exactly around 20. You can see from the vertical line. And what happens here is that the blue line, that is again our method with the our tunable method, is able to adapt better than the other two lines that instead are the fixed method, so the like something similar to what is in the literature, and the baseline. So the goal in this case is not only to be able to reduce the unfairness, but to be able to stay closer to the unfairness target, even when some hyperparameter tuning happens. This would allow a practitioner to mitigate maybe train again the model or fine-tune some hyperparameters, having more time to react because the system is still under the fairness target. So this is one of the future work and we are already working on it. The other one I already mentioned is the comparison with some other unfairness metrics. I mentioned the error rate, and yeah, that's all. Thank you.
So this presentation concludes this part of the workshop. So I also put a slide that summarizes some KPI of our projects related to this work package. And so you can see that there are different synergies with other projects because these topics are addressed also in different European projects. And I want to thank everybody for the presentation, especially because most of them are PhD students, so for them talking in front of you is one of the first talk that they did. So thank you guys, and that's all. Thank you very much. Clearly, if there are questions, we are available for that, but there is the coffee break also.
Okay, please, for the speaker, if you can achieve us in the table. Andrea is here. Francesco Bossi. Vito Giordano. Non me li devi vedere, me li devi chiamare, dai. Gabriele Gattiglia. Dove sei? Eccolo, vieni. Roberto Pellungrini. Antonello Romano. Ciao. Lucia Passaro. Dov'è Lucia? Ci sei già? Vabbè, se no io scendo giù, non vi preoccupate. Vai. Ci siete tutti? Ce la fate? Non importa, io vado giù, vai, non ti preoccupare. Cammino bene. Sì, è così da circa 2 anni. Ok. No, non ti preoccupare, state voi qui. Okay, ma voi state, non vi preoccupare. Can we start or not? Ho lezione all'1:30, quindi bisogna che prima o poi io inizio. Devo andare in ingegneria, tra l'altro. Okay, I think that we can start with this session on the number 7 work package. This is new, is a new entry in the sense that in the last workshop we didn't really talk about this work package because the work package was started later than the other work packages. The reason is that is a work package in which we focus on empirical studies and pilots of human-centered AI. The idea is just really to use all the research performed inside the FAIR partnership, and in particular, of course, inside our spoke, to really apply this research in some practical applications. And the task is co-coordinated by Dino Pedreschi, Raffaele Perego, Salvatore Ruggeri, and myself, and consists of 4 tasks. Task 7.1 was already developed, is the setup of an open environment for large-scale empirical studies. We just made the document, a sort of report about the infrastructure we have available inside the SPOC, and also some guideline for data and for software. Then we started the task 7.2. In this task, we organized all the pilots and use cases just using a form in such a way that for describing all these use cases pilot, we used the same type of data. Then we are monitoring now with the task 7.3 and this pilot use case. And we will listen today 7 of these use case pilots, but actually we have a higher number of these pilots and the use case. At the moment, we have 20 of these pilots use case, but I am sure that we have also other applications in the SPOC that are not really mentioned explicitly in this task. We have more than 60 researchers involved, and at the moment we have 11 papers already submitted and 8 already accepted. I told you that this work package started later than the other work packages, so also in terms of publication, I think this is a good result. Of course, we have also the last mission in this work package, that is dissemination. Also, this event is a dissemination, but most of the people involved in the SPOC are really make this dissemination action, not only in terms of journal or conference papers, but also participating in events and organizing events. We noted this in the presentation we had of the other WP, in which there are special section conference organized by people involved in the research in FAIR, and in particular in this POC. I think that we can start with the presentation. The first presentation is how can generative AI help a physicist, and the speaker is Andrea Rizzi.
Okay, thanks. So, this work, I'm Andrea Rizzi from the Department of Physics, and together here with Patrick Kazenov, and then we work with two PhD students from Scuola Normale, Francesco and Filippo, that are not formally in FAIR. So the thing I'll talk about is how can generative AI help physicists, and the first thing to understand that is how physicists do discoveries. The main thing is that we have, you see here on the left, big formulas that are the theories that basically nobody's understand, and the very complex experiments on the other side to try to measure reality. And we need to understand how to compare these two things in order to make a discovery or to measure something in physics. And it's not obvious how to do so. So the idea is that we basically repeat the experiment that we can do with the thing that you've seen on the right multiple times, like billion of times. And then we try to predict the probability that some kind of reaction between the particles that interact, that you can represent with the things on the left, what is the probability for that to happen? Both those things, the one on the left is somehow the representation that you have in the theory, and the one on the right is the thing that you can measure in an experiment. Both of them are what we call an event, okay, which corresponds to one of the billions of repetition of this experiment. And the idea is that we want to try to compare these two in some way. Now, to compare these two, the only way we have is to use Monte Carlo simulation techniques. And both on the experimental and the theoretical side, we need to work a bit on, on this kind of things. So I'm not sure you see any pointer if I do so. Do you? No. Well, that's horrible. So from the left thing, which is basically what happened at the microscopic level, you may want to really, from a theoretical point of view, get all the list of particles that are produced, and then you wonder how those particles interact with an experiment, how they go through matter, how we'll detect them, and both these things are done with Monte Carlo techniques. And then once you have both the representation of a theoretical event and one that you measure, you can compare them, and eventually you can look at basically distribution of events, and you have, for example, what you see in blue is what the theory will predict. What you see in black is what you measure in the experiment, and when you see something that you don't expect in blue, or in fact you expect but you still have to discover in this case, you can see that you observe something new. And for example, this is the way we observe the Higgs boson, okay? When you read about Nobel Prize about Higgs boson, it's all about seeing that little bump in red over there. And this is possible only because we can compare events from the theory and events, let's say, from the experiments. Now, how easy it is to create those events is in fact very complex, in the sense that to do the theory event, you need to simulate the event, and then you need to reconstruct events both for the theoretical one and the one that you measure. So by reconstructing, I mean you need to understand what happened in that event. And the computing cost of that is extremely high, okay? Now here is a unit which is a unit of counting of CPU that is used by physicists, but well, perhaps you understand better the thing on the left. We have exabytes of data produced annually by the experiment, especially by the upgrade of the experiment, by the future experiment we will have. And what we know is that the growing scale of our experiments is such that we may not be able to cope, even considering that computing costs will decrease, that we will get better CPUs and GPUs and whatnot. We may not be able, if we don't change paradigm, to simulate all the events we need, which is of the order of 50 billion simulated events every year. And I mean, you should take in mind that simulating on a single CPU one of these single events, it may take several minutes, so you multiply by 50 billions, and it's a very big number. Now, what is the idea that we are trying to exploit is to do end-to-end simulation. So if you look at this parabola there, what basically the classical simulation will do is you start from this theory representation, this sketch of there are a few particles that interact, and you can compute the probability of that analytically somehow. And then you go with the simulation all the way down to the details of what you will expect such a theory event will produce in terms of the readout of the sensor of the detector. Really, the electronics readout will give you 1 and 0s. This thing which we call raw data is exactly the same 1 and 0 format that you will get out of your detector. And then you need to go all the way up again, because you need to translate this 1 and 0 in saying, okay, what really happened in this event? Which kind of particles were produced? With which energy? And things like this. Now, what you can try to do in simulation, clearly you cannot do it for the real data, is you may want to shortcut this whole process and go from the far left to the far right in what we call an end-to-end simulation. So directly going from, okay, from theory we know that we may produce with this probability 3 particles of this kind. What we expect to see in the detector in that case, without going all the way to the details of the detector, like the 1 and the 0s of the electronics that you don't care about. And this is what we call end-to-end. So rather than going all the way with this simulation and reconstruction algorithm, we go directly to what we call an analysis dataset. And the idea is what? Is to try to do that with generative AI. Now, clearly, how do you use generative AI for that? You cannot just say, okay, can you generate an LSE event to some of the image generators that are there on the market? First of all, we need to be able to conditionally generate data, meaning we want to say, okay, I want to generate an event where there was an Higgs boson, or I want to generate an event where there was not an Higgs boson, and things like this. But even if you try to do so, clearly you don't get anything like that looks like what we have in reality, which is this is what you will need to simulate if you want, and this is what an AI that you find on the market may simulate. And in fact, images are not even the right thing to look at for this kind of job. And one thing to keep in mind when you generate images, I mean, we know that qualitatively you get very good images, and that looks like pictures, but we don't care just of this qualitative looking. We need a lot of care for the statistical properties of the datasets that you generate. So that means that if you generate 1,000 times this image, we care about the fact that the distribution of the number of people that are in the image is the correct one. And so it's not just that the single image should look decent or look like plausible, but we really need that to have, when you generate multiple of them, to have the right statistical property. So what we care about is probability density functions, and the idea is to use a technique in AI which is called normalizing flow to do that. So the idea of normalizing flow, for those that do not know about it, is that you have some data with some distribution that you see on the right. You learn a function which is invertible that transforms this distribution into a multidimensional Gaussian, or any other function you want, but let's say multidimensional Gaussian. Now you can easily generate on a multidimensional Gaussian because it's easy, and then what you can do if you want to get new data, if you want to generate a data set that has the statistical properties that you need, you just throw random numbers on the multidimensional Gaussian, invert the function that you take from the beginning as invertible, and you get your synthetic data. And this is exactly what we try to do. There are several techniques that we tested. This is much better suited than GAN, than generative adversarial network or variational autoencoders, because it really respects the PDF. That is the thing we care most about, whereas with other techniques, often you have some problem like mode collapse or bridging of distribution, and sometimes you may be accurate in mean and variance, but when you have long tails of distribution, it doesn't work. And now, clearly, we also tested some variations of these GANs that may be better suited at that, but we really had limited success, especially in our problems that are somehow different than the images, meaning that typically they have very low dimensionality compared to what generative AI usually does. Now, the results we got are very promising in the sense that we can generate distributions of observable that are matching exactly what you have here. You basically cannot distinguish. I mean, there is a dashed and a full line, and they are exactly on top of each other for most of the plots. And the thing that you see, the different plots there, is because, as I said in the beginning, we want also to generate conditionally, meaning that we want to say, okay, now generate a Higgs event, now generate what we call a W event or a Z event or a top event. Even if you don't know what they are, you see that the distribution should look different, and then we managed to do that correctly, which is more or less the same thing when you ask, okay, generate an image with a Colosseum or generate an image with a car. Now, did we get the improvement in terms of performance we were looking for in terms of speed up? The answer is yes, in the sense that depending on the scenario and the use case and what you want really to do with that, you can get speed up of 3 orders of magnitude or even more. So this is very promising. And the question is, okay, but is the accuracy just directly on the variables you generate or also on the derived one? Like, for example, as I said before, you generate an image of the Colosseum, but then you may want to count how many people are in there. And counting how many people is not directly one of the observables, one of the things that the AI generated. I mean, it just generated a picture of the Colosseum. Then you decided to go and count the people in the image. And that's an answer to that is this. Basically, we can compute some derived quantities, so not quantities that we directly generated with the AI, but that are, a complex formula coming out of multiple of those features, and that you should take into account correctly the correlations and so on. Even some, in some case, we use some DNN, some neural network to distinguish, for example, signal from background. And so exploiting all the possible correlation that we have in the events, and even the output of this DNN can be reconstructed correctly. So, and I really try to rush in the interest of time. In conclusion, we have this new approach for particle physics that we use generative AI to do this end-to-end simulation. And this seems very promising. The experiment we all work on, this group of people, which is the CMX experiment XR, is now exploring this technology and having an R&D effort ongoing to try to adopt this technology for the high luminosity LAC, which will start taking data in a few years. And you see here, if you want some reference of the documentation that we have, including some paper that we submitted. And you may have more details of the paper in Patrick's talk, in Patrick's poster this afternoon.
Thank you. Thank you very much. Thank you very much. And we don't have time for questions, so we can see at the end of all the presentation. And we have the second speaker, Francesco. Okay, thank you.
Thank you. Okay. Does it work by any chance? Oh, it works. Okay. Morning, everyone. My name is Francesco Bossi. I'm from the Department of Information Engineering. And today I'm going to show you an empirical study we performed about testing the effectiveness of Abel, our humanoid social robot, and its LLM-based cognitive architecture we implemented. We did this by employing an experimental protocol of human-robot interaction, basically. So, you probably already know everything about Abel at this point, but just to be really, really short, it's the hyper-realistic humanoid robot we're using at the Department of Information Engineering. And just to give you a very, very short part of information that's important for our study, 22 of the 43 servo motors that Abel is employing are actually just to move the face. So it can mimic in a very accurate way human facial expressions. In our case, Abel can mimic the movement of specific facial action unit in the facial action coding system, so it can mimic perfectly human expressions. Why am I saying this? Because at the same time, we tested in this protocol Abel's cognitive architecture. I'm highlighting in this case that we're talking about version 1 of Abel's architecture, because yesterday what you saw from Lorenzo and Federico's talk was actually version 3 for Abel architecture. So we made many steps forward. But you know, testing, collecting data from human participants, analyzing them requires time, so we performed this whole study on the first version of the architecture, and in parallel, we're moving on the development of the architecture. So, just a very schematic and simplified representation of the cognitive architecture. With Abel, we collected information from the microphone and the camera. These information were then coded by a voice activity detector and then translated with a speech-to-text, and the visual information was analyzed from a scene analyzer that could read the context in which Abel was interacting. This whole information was then fed to an expert system that generated the response with the first LLM that answered basically to the participant's question or sentence more in general. Then this information was returned to the expert system and fed to a second LLM that connotated the emotional connotation of this kind of sentence and gave for each batch of words, each sub-sentence, an emotional connotation for Abel's facial expression. This all information returned to the expert system that fed it to a text-to-speech to create the waveform of the envelope, and then gave instructions to the gaze, the jaw synchronization, and the facial expression of Abel. And all this information went then fed to the actuator of either the robot or the avatar, and I'll get to the avatar in a second. So, basically, this whole paradigm is into one of the general aim of FAIR, and the overall objective, as I said, was to both test the architecture of Abel and, at the same time, the embodiment, the effect of the embodiment of a physical social robot. How did we do this? We used a 2x2 experimental design within subjects in which we manipulated both the architecture, so we had both a smart version of the agent and a naive version of the agent. In our case, I won't get into much detail, but the naive version is basically an LLM put on top of the agent. And at the same time, we manipulated the embodiment, so we used either Abel as an interactor or an avatar, just a non-screen avatar. How did we test how the interaction was perceived by the participants? We used both a self-report behavior measure. In particular, we used the human-robot interaction evaluation scale, which I really recommend because it has great psychometric properties. And it identified 4 different factors for the interaction, which are agency, animacy, sociability, and disturbance. And we also collected physiological data. In particular, we collected electrodermal activity and heart rate variability, which are basically indices of autonomic nervous system, so how much the participant is activated, the arousal of the participant. As I said, we used the avatar as a sort of baseline, and we used OpenFax because, first of all, it really resembles a lot Abel in its current form, and also this kind of avatar, online avatar, can allow us to move, as I said, a single facial unit of the avatar, which is the same thing that we did with the emotional expressions for Abel, for example. The whole experimental procedure consisted, as I said, in 4 experimental conditions, so smart Abel, naive Abel, smart avatar, and naive avatar, all counterbalanced in order across participants. And each condition consisted of a 10 minutes interaction. How did this interaction was made? It was, each interaction started with 5 scripted questions, where the first one was, "Hi Abel, how are you?" which is the title of this talk. And it also included typical areas of human, let's say, intelligence, or in general characteristics, so empathy, mathematical reasoning, trivia, and ethical questions. We did this to basically for comparability. So we knew that the first part of each interaction was the same across all participants. One of the main novelties of our work is that the remaining time of each condition was completely free interaction. This is quite rare to find in the literature right now. The voice activity detection was visible to participants as basically a traffic light. So if you see red, don't talk, because Abel is thinking, so it's either processing or is actually talking. If you see a green light, you can talk. Abel is listening to you, basically. And as I said, we collected physiological measures. Very briefly, our main results on the behavioral data is a main effect of both the embodiment and the architecture on 2 of the 4 subscales we used, so sociability and animacy. What does it mean? Basically, we found that the architecture version of both the Abel and the avatar are felt as more sociable, friendlier, let's say, and more human-like than the no architecture version, here represented by the green line. At the same time, we found that, on average, Abel is perceived as friendlier and more human-like than the avatar. The embodiment effect is no big, let's say, is not a great novelty. We already knew this from the literature, but it's good to replicate this on Abel specifically. And also we performed some simple effect analysis on all 4 factors, and we found that on animacy, the effect of architecture, so this difference that you can see, is significant, statistically speaking, but not this difference in the avatar. So this result tells us that basically using a proper cognitive architecture is crucial for a human-like interaction, but it's best to work in synergy with an embodied robot, because embodiment is crucial for this kind of interaction. We also tested some manipulation check analysis, on the pre-scripted part of the interaction. A very important thing, the questions were scripted at the beginning, but not the answers. The answers were generated by the architecture each time. And we saw that the architecture version is always, creates always sentences with lower entropy, a lower number of words. The no architecture version was very talky, and also with fewer repetitions. And this is very good, as the interaction was actually perceived as more natural from this point of view. So the future steps, we're actually right now analyzing the physiological data that we collected, and we hope to find coherent results, of course, with what we found from the behavioral point of view. And then for Abel, the idea, the futuristic idea, the long-term perspective is to collect all biomedical signals from the participant with Abel, so basically the gaze, the pupil dilation, which is another important index of autonomic nervous system, but also central nervous system, by using, for example, EEG, speech characteristics, bioimages, and extract features from all these signals to better understand the emotional state in that specific moment of the participant, to create a more natural and spontaneous interaction with Abel in the best possible way. Many thanks.
Thank you. Thank you. Thank you very much. And we proceed with the next presentation now. And please, Vito.
Thank you. So, good morning to everyone. Today I will present you how the application of natural language processing to the identification of engineering concept from patents. First of all, I am Vito Giordano, an assistant professor from the desk department at the School of Engineering. Here you can see other people involved in the project. I will start with a brief introduction about the field of application. That is new product development. New product development is the process of creating and developing a new product or service using problem-solving techniques. And here you can see the main phases of new product development, starting from the problem definition, so the technical problem that the product should solve, and ends with the developing and designing of the product to the final user. This process is a knowledge-intensive process, where the knowledge is saved in document, in visual and in textual format. Here you can see on the right different documents that are involved in the new product development phases. One of the most used in this stream of literature is the patent. Patent is the description of an invention, and so contain the knowledge of the inventor in a given for a given technology. Here you can see the example of a patent and the knowledge that is stored both via text and image. So the automatic analysis of patent can be useful for a lot of applications that you can see in this slide, from the generation of novel idea to the mapping of a technological field. And however, in these applications and in each phase of new product development process, engineers and other technical experts involved in the process think and are focused on a given key concept. Here, for example, you can see that in the first phase, in the problem definition phase, the expert is focused on understanding which are the needs of the user that the product should satisfy. And so it's demonstrated that focusing and extracting this concept from text or visual data can be useful for an artificial intelligence system, a decision support system, for many engineering applications. So today I will focus on two main concepts of the new product development process that are function requirement and product parameter. To understand the importance of this concept and the importance of the relation of these two elements, I show you in the slide a table. The main function of a table, of the legs of a table, is to stabilize the structure of the table. So the function requirement of the legs in this case is to stabilize. And the number of legs are a physical characteristic of the object that the engineers can use to manage to lead the functional requirement of stabilize. So in this case, number of legs is the product parameter. This information are contained in patent document and can be extracted using natural language processing. To doing so, we first collect a set of patents, then we annotate this patent to train an encoder-based model based on BERT to extract this information from textual data. Then we compare the performance of this model that we trained with different large language models on different natural language processing tasks. Here you can see the data set we annotated is composed of 6,000 sentences where different engineering concepts are recognized. You can see the different concepts on the table on the right. And using this data set, we can perform different natural language processing tasks: sentence classification, name identity recognition, and relation extraction. The document is annotated in part also by two human evaluator. This for two main reasons. First, to understand the difficulty in a given natural language process task that we measure with the FA1 score that measures the agreement between the two annotators. And second, to test the performance of the encoder-based model that we trained after. So here you can see an example of the different natural language processing tasks from the sentence classification, name identity extraction, and at the end relation extraction. Here you can see the performance. So using this data, we trained a BERT model, and we compare the performance of BERT model with other generative models using prompting. Here you can see the performance for the sentence classification only in terms of both effectiveness, so precision, recall, F1 score, and efficiency, so in time and cost of performing the task. And here you can see basically that the encore-based model is more convenient for both in terms of effectiveness and in terms of efficiency. This is also useful for understanding how to apply this technology in a business context. For the same reason, here you can see how the performance of encoder-based model changing the size of the training. And to answer basically to the question that you see on the slide. And here, another example for the name identity recognition task, in the case of identification of product parameter. And also here we compare the different performance for the different large language models. Basically, at the end, using this model, we are able to extract in a given case, like this on a protective mask, which are the function requirement and the product parameter, and how these two elements are related. Here you can see some sentence extracted from patent containing both element and also the relation between these two elements. So in concluding, on the right you can see three main points to summing up, but the one that I want to focus now is that although these results seem obvious for computer scientists, these are not obvious for other research fields. I know that in the last year, a lot of people attempt to use generative model for a lot of information tasks. So one main question is this always a reasonable choice, and for which business context? So thank you, everyone.
Thank you very much for also this presentation. What is interesting that we have really different domains, and this actually, in some way, the context in which we are really presenting this application in different domains. This is very interesting, I think, because testify that, of course, the AI is very pervasive today. It can be applied to different domains. And just talking about another domain, we talk about archaeology, and I leave the floor to Gabriele Gattiglia.
So thank you very much for inviting us. We are working at MappaLab, that is a research unit at the Department of Civilization and Form of Knowledge. And thanks to FAIR, I'm the one with the long black beard. Thanks to FAIR, we are now involved in many projects related to AI. We are coordinator of an Horizon Europe called Automata, and we are the chair of a cost action called Maya, managing AI in archaeology. And if any one of you is interested in discussing in this network with us as archaeologists, is invited to apply for this action. And then we are involved also in a ERC project called Aviarc. So very, very thanks to this opportunity of working with FAIR. We work in AI and archaeology, trying to define many of the challenges in these fields that are enlisted here are mainly related to data availability and also technical challenges in working in this field. But we are very interested also in the aspect of hermeneutics and technological agency, which means how our discipline, archaeology, is changing through AI. So also archaeological practice is now changing due to this technology. And all these epistemological changes are also related to the materiality of AI. So as archaeologists, we are not only interested in software or in this part that is more virtual, but also in the materiality on all the digital apparatus. So, after this short premise, I leave the floor to Quirino Saraceni, who is a PhD student and is working on this project.
Good morning, everybody. I'm Quirino Saraceni. I'm a PhD candidate of the AI National PhD program. And together with Professor Gattiglia, we have been working on integrating AI and robotics into cultural heritage and archaeological research. Today, I'll be talking about our pilot case, the use of an AI based on Arcade, acronym for Archaeological Automatic Investigation and Documentation of Ceramics, a system designed to help automate the classification of ceramic fragments using AI to sort automatically ceramic shards with the aid of a robotic arm. Let's start with Arcade itself. This system, funded by the European Union's Horizon 2020 Research and Innovation Programme, was developed to address a significant challenge in archaeology, classifying and documenting ceramic fragments dug during excavation campaigns. Traditionally, this has been a long and boring manual task, requiring expert knowledge and a lot of time. Arcade automates this process using AI. It can recognize ceramic shards through a PC or even mobile devices like smartphone or tablets. What's particularly useful in this task is that it outperforms human classification in many cases, making it an incredibly valuable tool for archaeologists. The system was originally built using TensorFlow 1 and ResNet 101, but over time the framework became outdated, in particular TensorFlow 1 and its libraries. And for this reason, we have decided to port it to PyTorch and experiment with different neural networks like ResNet 50 and Google Inception v3 to improve its accuracy and efficiency. One of our key aspects of our research was the improvement of Arcade to get Arcade learn over time. And this is where continual learning comes in. In a traditional AI model, as you know, once training is complete, the system remains static. It doesn't evolve unless we retrain it from scratch. But that's not how real-world data works, because as archaeologists discover new types of ceramics, we need a system that can adapt to them. With continual learning, Arcade can add new classes of ceramic shards without having to retrain the whole model, update its classification knowledge over time without forgetting past data, and even potential with a meta-learning strategy, self-discover and learn new classes that it hasn't seen before. This makes the system far more flexible and scalable for long-term use in the field and also for other uses that can be related to cultural heritage. Now, we faced also another problem. That is in the use of Arcade as a manual step involved. That is, someone has to take the picture, verify the classification, and then physically pick and place the fragment in the correct box. And here is where robotics can help us. Every excavation site, in fact, and archaeology lab is filled with hundreds, sometimes thousands of ceramic fragments dug during excavation campaigns. Sorting them takes time, effort, and expertise, and it is a very boring task. By introducing a robotic arm into the workflow, we can automatically automate the physical handling of this fragment, speeding up the process and reducing the need for constant human intervention. Now, let's talk about the hardware we chose for this project. You know that robotics can be very expensive, and high-end robotic arms often cost thousands of euros. But we need a more affordable but capable solution. For this reason, we chose that robotic arm that in the picture, the Tinkerkit Braccio robotic arm, combined with Arduino as a controller, because it is low cost, but still provide good performance. It's open source, meaning anyone can even 3D print and build their own version, and it's modular and easy to program using C++, making it customizable and upgradable. This makes it not only useful for our research, but also a great tool for education and experimentation in this as in other robotics application. And also the use of an open source software is just as important as for the hardware, for the development of our project. For this reason, we choose ROS, that is the Robot Operating System, and the MoveIt as a motion planner, which are open source frameworks widely used in robotics. Why we chose these two frameworks? Because they are flexible. They allow us to modify and tailor the software to fit our needs. They are interoperable. In fact, they work with different robotic platforms, making it highly adaptable, and they are scalable. That is, we can integrate new components, sensor, or even new AI models without having to start from the scratch. And ROS and MoveIt has a huge global community, so there is a lot of documentation and support available over the internet. And another key feature of ROS is its embedded simulation environment, that is Gazebo and Arviz. In fact, before we deploy, we use the robotic arm in the real world, we need to test it to avoid risks and damages, and for this reason, the simulation must be very close to the real world conditions and physics. Gazebo and Arviz provide a safe and realistic testing environment. In fact, the physics simulation models things like gravity, friction, and collision, making the test accurate. And in Gazebo, we can integrate sensors like cameras and LiDAR, giving the robot a virtual view of its environment in a very easy way. And this is a crucial fine-tuning for the robotic process before deploying it on the actual fragments. Let's take a look on how the algorithm works, that is how the workflow is. First thing, we have to capture an image. You can see the first picture on the left. Then we have to segment the image, the second picture, to isolate the individual fragments and to measure each fragment. Then we run the AI model to classify each fragment, assigning a label and a confidence score. And then we do some analytics on this data. That is, we group fragments based on confidence level and statistical analysis. And the robot will pick up fragments which belong to classes with highest meaning confidence level and lowest standard deviation. Then, if we go on, let's see the robotic execution of the pick and place task. The classifications are converted into a ROS message, which are published and spread out through the system to the other components. These messages are then processed by the motion planner, that is MoveIt, to determine the best pick and place pose for the robotic arm, and then the robotic arm tries to pick up each fragment and place it in the correct bin. This entire workflow is completely automatic, ensuring that fragments are sorted efficiently without human intervention. Another key aspect of our research was that picking up objects for a human sounds simple, but for a robotic arm, it's an incredibly challenging task. In fact, fragments are very particular object. Why? Because fragments comes in different sizes, so the robotic gripper needs to adjust its finger accordingly. They are surrounded by other fragments, so the robot must carefully navigate without disturbing the other. And some fragments are tilted or irregularly shaped, meaning the robot must analyze the best way to grasp them. For this reason, to tackle this, we use the GPD, the Grasp Pose Detection, a deep learning-based method that, using 3D point cloud data for sensors like the camera we integrate in the system, we can see this is the D435 Intel Real Sense camera, learns which grasping position are the most stable and can work in cluttered environments without needing pre-trained object models. These make the robotic arm smarter, adaptable when handling archaeological fragments. So, a lot of things we have to explore more. That is, continual learning can be improved, grasping strategy can be further refined, and also we can expand the system to handle other type of artifacts beyond ceramics, like in the automata project that Professor said a little before. And thank you for your time. Okay.
Thank you very much for the presentation. And we change again our domain, and I just invite Roberto Pellungrini, and I leave the floor to you.
Thanks. So, good morning. I'm Roberto Pellungrini from Scuola Normale Superiore, and I'm going to present to you a work that we did in collaboration with UNIP, the Department of Computer Science in the person of Anna Monreale, and the Department of Biology with Giulia Peduzzi and Daniele Campa. And the idea of our work is essentially to study and understand the reasons why we develop a certain particular type of cancer, in particular ductal adenocarcinoma. And we do this by using explainable AI. So just a few informations about this type of cancer and why we chose this particular disease. There are two different types of pancreas tumor. One is the pancreatic neuroendocrine cancer, which is less common and has a generally better outlook. While the most common type of cancer is the pancreatic ductal adenocarcinoma, which strikes 85% of the people that develop a pancreatic cancer. And unfortunately, it has also a fairly bad outlook because the average lifespan after diagnosis doesn't really go beyond the 5 years mark. even with treatment. So it becomes really important to develop some early screening procedures that, given the data of a person, can allow us to understand if this person has a high risk of developing this particular disease, because in this way we can treat it in time. There is, however, a big problem. This particular type of cancer is one of the least understood and least known in the literature regarding cancer. There is very little that is known about the reasons why people develop this type of disease. And mostly what has been done remains in the field of pure statistical, let's say, correlations. And so different risk factors have been singled out. But the p-values generally, or the statistical powers for these analyses, remains quite low. Also because, fortunately, this is still a quite rare type of cancer. So, in essence, it is difficult to pinpoint a reason or a single, let's say, variable that we can look at and say, okay, this person has a high risk of developing this type of cancer, and so we have to keep an eye on him and maybe start treatment soon. So the idea of this research was to find as much data as we possibly can and also add some more, let's say, information to the simple, let's say, risk factor analysis that was done before, in particular using polygenic risk scores. Okay. So where we started from a huge data bank, which is called the UK Biobank, which is a data set which has been collected by the National Health Institute of UK, of England, where there are more than 500,000 participants. And in this particular data set, we have a lot of different variables and a lot of different characteristics that we can look at, ranging from exact blood values, for example, but also environmental characteristics, which are really interesting, like, for example, lifestyle or the place where the person lives, etc. Not only that, but in this data set we have also extensive genetic data, in particular genome-wide genotyping and exome sequencing. Okay, so the basic idea is, since we have for each person both the environmental variables and the genetic information, we can try to understand if, by using machine learning models, we can use the combined information to realize a early screening tool that allows us to understand which people have a higher risk of developing adenocarcinoma. And also, using experimental AI, try to understand if there is some interaction between the genetic information of each person and the environmental variables, that is, how the person lives. So, a few numbers. This work, let's say, could be divided into two chunks. The first chunk that is data cleaning, data preprocessing, and data preparation, which took roughly 70% of all the work. Why? Because, unfortunately, UK Biobank is a really huge database, but it is very coarse, and there is a lot of noise in this data. It's very noisy database. So indeed, what we did is to try to clean up as much as possible the data and select appropriately both controls and cases in a way that we could develop effective machine learning models. And indeed, here we face one of the, let's say, greatest problems when studying this type of cancer, that is the very low number of cases. With respect to the entire population, we only had little more than 800 cases with this particular cancer. So what we did was to essentially clean up all the data and start the selection of the variables that were more interesting to us. And in particular, what we did, we applied some statistical cutoff, especially, for example, the Bonferroni cutoff, to select the variables that were more promising in studying this particular disease. The other thing that we did is we took all the genetic information of the people represented in the data and we computed the polygenic risk score. The details you can find in the papers that we published on digestive liver disease, but essentially the polygenic risk score is a score that counts, if you want, the bad alleles in your genome. That is, the alleles that could essentially put you at risk of developing this disease. And after you detect these alleles, you can essentially count them and produce a score that highlights how much your genome puts you at risk of developing this particular cancer. So this is a general outlook of the workflow. We prepared 2 different data sets given different, let's say, selection criteria for the statistical power of the variables that we selected. And then we applied 5 different machine learning models, all, let's say, fairly robust and state-of-the-art for tabular datasets. We also, in the meantime, we are also starting to experiment with other models, for example, small large language models specifically tailored to handle tabular data, and also simple dense neural networks, even though perform very small example. What we found is that we were able to approximate our opaque models with the decision tree up to a certain degree. And this is one of the points where we want to work a little bit more, because indeed we are able to see the patterns for especially for cases, but for controls, but for cases we have, let's say, unsatisfactory performance, at least for now. So this is something that we want to work a little bit more in the future. And so, yeah, this is just a general overview of what we did and our directions for the futures. So thank you for listening, and sorry if I ran out of time.
Thank you very much. Thank you very much. And I wanted just to interrupt, but it's quite late. Okay. And we have the next speaker, Antonello Romano. We change again domain. Okay, just I leave the floor to you.
Yeah, thanks. Good morning to everyone. We are geographers, so as geographers we are interested into space, space relations, space dynamics, patterns, as well advanced geospatial analysis, emerging methodologies. So in this sense, we present today these case studies which concern geospatial artificial intelligence and urban mobility between predictive modeling potentials and some challenges related to the geospatial data accuracy as an input within such models. In detail, this contribution fits within the second research line that we are developing as part of the field project, which experiment geospatial artificial intelligence process and new models, emerging models in urban studies. And in particular, within these case studies related to the urban mobility and the connection with other territorial and geospatial components. Also, we want to frame this case studies. We would like to consider this case study as an advancement compared to a work currently under review, which concern the nexus between workability and heritage here in Pisa through GeoAI, so by employing GeoAI, while today GeoAI becomes more the subject, the object itself for this case study. In addition, we would like also to fit these case studies within a broader context of widespread practice of using the data employed in the study that we see in a minute by public administration, even in Italy. So at the end, we would like to discuss the impact of AI-driven systems on our ability to correctly interpret the geographical reality that is around us, and so in consequence, make or take spatially informed decisions correctly. The framework is that of the GeoAI, that is quite known. It is the application of AI techniques to geospatial data that we can consider at the intersection points between big data and spatial big data, AI and geographical information systems. Also, we need to frame this work. We did some symbolic AI that is quite known to you, but it's an emerging field, an emerging topic within the geographical domain, which involved use of ML methods and neural networks to analyze spatial data and patterns. And so our question is, what consequence in doing so within the geographical domain and in our society? So the research question concerns what is the degree of spatial accuracy in GeoAI models, and what is the difference in this regard between traditional linear models in advanced in spatial analysis compared to neural network models, so more AI-driven methodologies. The data employed comes from Strava, that is an application, an app, digital platforms used to track and share athletic activities worldwide, like cycling, running, even swimming. This platform counts 95 million users worldwide that shared 700 million digital tracks worldwide. So basically, from this massive amount of data that we collect, or we display it here within this globe map, we extract the data that reference the province of Pisa, the blue map on the left, by focusing on walking data. So basically what we do, we collect the Strava data in 2 moments in time, 2022 and 2023, in order to produce this sort of spatial benchmark between the prediction and the real data that you collect later. It also worth noting that data format consists of daily values for each OpenStreetMap edge. So this means that OpenStreetMap becomes the road network for this exercise, becomes the base map for the map, of course, but becomes also the network of this model. Basically, to each OpenStreetMap edge that are really single piece of the road, we can attach the count, the value of intra-contra flow, recorded daily in 1 year, here in Pisa. So based on this longitudinal and spatiotemporal data, we experiment with a deep learning framework that we embed in a GIS environment that works with vector data, not raster data. This is not a secondary point because we consider space differently, not as an Euclidean surface. And we basically produce a space-time cube for the training of this model, since we have different points in time and different values attached to it in different moments in time from the same locations. So the space-time becomes the model, the trainer for this model, and each intersection between 2 segments becomes a node of the networks. We ended up with this map, the yellow to blue map, that is the DL prediction. We compare with the real world data that is the map, the blue map, the real data 2023. So basically, it can be observed that the granularity of this source and the spatial structure can be really interesting, as well as other mobility data, since they allow for the identification trends that happens at intra-urban scale, but overall the prediction of future trends with a high degree of spatial accuracy. As you can see here, the spatial similarity index between these 2 vectors is really, really significant, is really high. On the opposite, on the contrary, if you try to predict by employing a traditional linear way of thinking, a traditional methodology, and compare the deep learning methodology to the linear, so what we have till now, basically, we can see that the deep learning models show a greater ability to adapt these complex patterns, spatial patterns, and producing more realistic results. In contrast, the linear prediction model, being more transparent to us, allow for a better understanding, of course, of the relationship between the input and the output. So how this happens, how can we manage with this, how can we deal with these results? In addition, we also confirm, as I already discussed past year workshop, the importance of human control over input spatial data, as some of these walking trips, as you can see within this map, are recorded on the Philippi Highway. And this is quite strange, of course. Others are on the airport's runway. And this is because the nature of this data, the nature of the crowdsourced geographical information, it is well acknowledged, well studied also within our research group. But we are aware about this. The question is if systems are aware about such limitations. And as previously demonstrated, the spatial data as an input matters more than ever within this historical moment, where the risk is to produce disinformation, misinformation, so not voluntarily, and at the end, asymmetric results, so asymmetry compared to the reality that is around us, that we want, thanks to these systems implementation, we want to predict, we want to interpret and shape or plan. And at the end, the risk is to produce fake geography. So this work has been published recently, talks about the synthetic geospatial data and what the consequence in the production of data by algorithms, for algorithms in a cumulative, reiterative mechanism, which is give us the, not give us the chance to distinguish between what is real and what is synthetic, for example. In conclusion, this study tried to demonstrate how GI can enhance urban mobility analysis through predictive modeling between potential and challenges related to geospatial data accuracy and model transparency. As already discussed yesterday morning, one of the most heard words was opacity, how to, the model is opaque, how to deal with this. It seems that deep learning models outperform traditional approach in adapting to complex patterns, but really raise epistemological concern due to their black box nature. Also challenging the integration of fundamental geographical principles. We are not in a geography conference, but it will be my presentation if so, because really we are embedded some rules without considering basic geographical fundamentals. I'm thinking to the first law of geography, the Tobel's law, the second and the third law of geography, on which geographers until now based their all knowledge, basically. And consequence, our interpretation of the geographical reality, and consequence, decisions that we produced in relation to. And from a technical perspective, it seems that the better performance, on the contrary, what we can think, emphasize the need for accurate geospatial data input, reinforcing the importance of human oversight to maintain the data quality and contextual relevance. From an epistemological point of view, the rise of some symbolic AI invites more critical reflection, at least within my community and within this community, on the implication of delegating spatial decision-making to autonomous systems. Since, as you know well, we are going towards forms of autonomy that goes beyond forms of automation, where the risk is to skipping human control. And generally, these studies call for a more balanced approach that combines the predictive power of AI with rigorous geographical analysis and fundamentals. So in conclusion, we would like to leave the floor by kindly let you read this slide, the black part of this slide, if you want. It will be a little bit provocative, where we imagine the opposite. We imagine ChatGPT ask a human. Thank you.
Thank you very much. And we are in the last presentation, and I just leave the floor to Lucia Passaro.
Thank you. Good morning, everyone. My name is Lucia Passaro, and the case study I'm going to present now is about fake news, from detection to psychologically tailored debunking. So this case study has been partially funded by a PRIM project made in collaboration with the University of Padua. Psychologists in Padua are studying the psychological profile of people who believe in fake news. And on our end, we are studying automatic ways to detect fake news and automatic ways to debunk fake news based on the different profiles of the readers in practice. Well, the detection of fake news at the very basic case can be approached as a binary classification task. So we have a piece of text that can be an article or a social media post. And we have to decide if this text is fake or real. So the problem when we approach this task with supervised learning is the fact that the fake news detection datasets we use for learning are very small in size, and also the fact that they are very heterogeneous in terms of data types, in terms of topics, and so on and so forth. So the problem is that the models we build suffer they are not able to generalize on new data. So the first outcome of this case study is an experimental comparison of the various approaches based on machine and deep learning we can use to detect fake news effectively. And in practice, we studied 10 different machine and deep learning approaches, spanning from traditional ones based on support vector machine up to recent large language models. And we experimented with 10 diverse data sets of different size and type. And in addition to traditional experiments, which are typically dataset specific, where the various approaches are effective, we experimented with cross-dataset experiments, and by mixing a little bit the input to see to what extent these models are able to generalize across dataset. From this study, we have seen that also modern large language models struggle in generalization, that there are not universal features we can use to separate in a reliable way fake from real news. And we also have seen that new approaches are required, maybe by surpassing the idea of classification, or that we need highly engineered systems to detect fake news and to adapt the model over time. The second byproduct of this case study is a monitoring platform, where we simply scrape newspapers online, we collect daily headlines and articles, we organize them along topics and keywords. From these topics and keywords, we extract some trending topics, and we use such trending topics to search for fake news fake and real news in social media. At the end, we store all of this textual data for detection and debunking. Once we have collected and predicted our fake news, it's time to debunk our fake news. And the idea here is to adapt our debunking strategy to the profile of the reader. So the idea is that we can maximize our chance to convince our reader if we adapt the debunking to their psychological profile. So this is an example of a well-known fake news. This picture is actually fake, and this news has been debunked by Snopes. So we see Zelensky and his wife posing with stacks of money. So this picture has been obtained by mixing two true and real images, but the output is misleading. So the factual debunk of this news says that this photo is not genuine. It is a combination of the original of an original photograph depicting Floyd Mayweather and another picture of Zelensky and Zelenska posing for Vogue in an article appeared in 2022. So the idea is that starting from this factual debunking, we can use a large language model to adapt our debunk to the psychological profile of our reader. So we provide the LLM with the fake news, with the factual debunking, so with some evidence that show that our news is actually fake. And also, we provide the LLM with the characteristics of our reader, so this profile of our persona. And the idea is that we can, if we have to debunk our fake news with a sensing profile, we will use a language much more oriented to factual evidences where we show a lot of facts. So it's similar to the factual debunking factual debunk we used as an input. While if we have to present this, we have to debunk this fake news with a feeling person, we will go with another type of language by evoking particular emotions, highlighting the harm of misinformation, and so on and so forth. So this is an example of what we can present to a sensing and feeling person. So we have more or less the factual debunking for the sensing profile, and for the feeling profile, we present some evidence. We explain that the picture, that the news is actually fake, but we also add something like false images like this can mislead people, and we call to emotions to capture the attention of our reader. So, to sum up, detecting fake news remains a very challenging task, also for advanced AI systems and for large language models. We know that typically misinformation spreads faster and faster with respect to debunks. So instead of debunk faster, we can try to debunk better and to maximize the chance to convince people to not believe in fake news. Thank you for your attention.
Thank you. Fantastic. Very fast. Thank you very much. And we terminate this section. In my opinion, it was very interesting because it gives us the idea of how we can apply really in different domains what is today the AI. And the speakers really analyzed different domains, but also gave a very interesting solution by exploiting the novelty of the AI today. So I strongly believe that this should be also in some way the way to disseminate what we are doing in terms of innovation and research. Thank you very much for your presentations. And I recall you that we have the lunch now, but please, at 2 o'clock, we have just to start very precisely because we have a connection with other people outside. Okay? Thank you. Bye-bye.
Sentite? Vabbè, oh. Okay, ladies and gentlemen, I think we can begin our next session. We have 2 more sessions in the afternoon before the end of the workshop, and the next one is dedicated to transversal projects of FAIR. Not all the transversal projects, but those where we are mostly connected in our spoke. We have 4 transversal projects represented by Davide Bacciu from the University of Pisa. Roberto Navigli, who is not here, he is in Geneva, will be hopefully connecting with us on Zoom shortly. We have Giulia Olivato from University of Trento and Fosca Giannotti from Scuola Normale Superiore. The first speaker is Davide on the continual learning project. Davide. So it's here.
Okay. Thanks, Dino, and good afternoon, everybody. I'll try to keep my time here. Just scream if I'm going over time. Pleasure to be here. This talk is going to be about activities that are related with the lifelong learning, continual learning, transversal project, and just to give a better scope to this talk, I decided to name it Continual and Tense Time Adaptation for Sustainable AI. The reason of that will become evident as soon as I progress through the slides, but essentially when we speak about lifelong adaptation as a more general term, there is not only continual learning as such, so the continuous training of model parameters, but there are starting to be a plethora of different approaches being used to adapt the behavior of an AI agent at test time, a prediction time, continually throughout its whole lifetime. And, well, sustainable AI is there because at least those that are part of this transversal project believe that it's a key research area to ensure a sustainable development of AI under many different perspectives. So this is a joint collaboration of multiple research groups spanning from Pisa, Catania, and Trento, and the results you're going to be seeing there are a mix of these. So just very quickly to position the transversal project in FAIR, it mainly crosses three work packages in FAIR. One that has to do with, let's say, work package 1.3, where we talk about human-centered lifelong learning, so it's naturally connected to that, and is rooted in Pisa. One that is about integrating multiple modalities in AI perception, that roots in Trento, and where, of course, efficiency aspects when we talk about foundation models become, adaptation of foundation model becomes central. And then one that is instead more looking at the biologically inspired aspects and connected with cognitive architecture aspects of lifelong learning. In the end, the best lifelong learner are the people, are the agents in this room, so are the humans. We are quite good at that. At least most of us are. And what is the challenge? So just to keep positioning, when we talk about lifelong learning, the challenge is that of enabling open-ended learning or adaptation. I should have been using the word adaptation. So never stop adapting, developing methodologies that will allow AI agents to be able to adapt their behavior, their prediction throughout time without a clear and sharp division between the adaptive training phase and the static deployment into an environment, into an operational environment. This essentially comes down to finding ways to consolidate knowledge, because one of the aspects that is key when you allow a model to continuously adapt is the so-called plasticity, let's say stability plasticity dilemma. The fact that in the end, if you allow a model to, an agent to continuously adapt its knowledge, what may happen is that you forget about
what you knew, because you start chasing what you're experiencing now. And so mechanisms for knowledge consolidation are fundamental. If you're learning throughout time, you need lesser supervision. And some of the examples that we're going to be seeing today are about learning or adapting under lesser forms of supervision, because you can't expect that there is a human following the AI agent and telling to the AI agent, no, you should have done that, no, you should have done that, you should have predicted that throughout the whole lifetime of the agent. Pretty unuseful. And compositionality is another aspect, because we're talking about something that is sort of aiming at chasing human level performance, and humans are very good at composing existing knowledge and reusing it to learn how to solve different tasks. Okay, so this is also a key aspect that we would like to tackle. And, well, biological plausibility, because some of us believe that having a sort of biological plausibility is helpful on both ends. And the other aspect that we deal with is, as I was saying, sustainability aspect. The ability to continuously adapt is fundamental, both for environmental sustainability, because you sort of break the need for having to retrain a model from scratch every time you need to change anything, and that clearly has computational and energy and environmental impacts. But that is also connected with societal impact, because whenever you realize that a model contains information that shouldn't be there, because it's private from some information, because it's information that should not be divulged, it should be removed from the model. And if the way of removing that information from the model is retraining the model from scratch, that is not sustainable. Okay? We need mechanism to make this process of dynamic patching of models sustainable, especially as AI models are going to be deployed as any other software piece in real life and maintained through time. The way in which we develop software is we maintain software. We update it constantly. We don't rewrite it from scratch every time we need to update it. We patch it. We need ways to dynamically patch models. So what I'm going to be looking at is sort of the general view of lifelong learning, trying to show that lifelong learning is something that spans across paradigms. So I have sort of handpicked or cherry-picked some contributions that explicitly shows the fact that you can find continual learning when you're talking about foundation models, which have certain characteristic, that you can have continual learning in very simple agents that learn online, such as in the second bullet point. You can have advantages of continual learning when you work with distributed multi-agent systems, and when even these systems are even less loosely coupled, such as in swarms that evolve according to evolutionary laws. Now, very quickly, so what I'm going to be doing is, let's say, presenting very quickly some contributions, and I'm going to be happy to answer to questions if you have any now, or directing you to the authors, because there is not much time to get into the actual science of it. You can already see that the porting from PowerPoint to Google Docs has destroyed everything, but don't worry, it's just numbers. So the first thing that I would like to highlight is the fact that, for instance, if you consider foundation models, one of the key aspects in foundation models is how to adapt them using low-rank methods that kind of restrict the parameters that are affected by the adaptation, by the fine-tuning of the foundation models. Now, we all love LoRa and a method alike, but what happens is that these methods are thought for assuming that there is some sort of stability in the data generating process. What happens if I put myself in a scenario in which data generating distribution shifts across times? Do the assumptions that are underlying model merging in these models hold? The answer is actually not so much, and you need dedicated approaches that are developed specifically to make sure that you can take, for instance, LoRa's from different specialized foundational models and merge them in an adaptive way. So taking into consideration the fact that these tasks are not the result of different views of the same distribution, but they're actually the result of multiple distributions. And that's what this paper here essentially shows. This is what I'm doing for the Italian speaker is the bignami of a full paper in like 30 seconds. Apologies for that. Another way to look at the lifelong adaptation aspects is to look, rather than at the learning phase, at the prediction phase, but making it adaptive at test time. So making sure that the prediction of the model changes, okay, without necessarily changing the parameters of the model. So when we're talking about test time adaptation, for instance, we're looking to ways in which we can prime the model through prompting in such a way that it can answer, for instance, to unknown, to queries about unknown visual classes. The way this has been done, for instance, in a let's say very smart way in this work is essentially to take some assumption about this, let's say, prompt tuning mechanism and relax them to the point in which you don't actually need any adaptation and you just predict, so source in input to your foundation models multiple views of a single test instance that is unknown, okay? And then, let's say, being rooted on some theoretical consideration, you can show that through different manipulation of this input piece, you can reach a consensus on a prediction on this new piece of text, test. The key, the new sample which you want to predict about. The key thing being, and we're sort of classification settings, that the key aspect is that you need to control the temperature of the softmax that is producing the output. Why? Because that makes the model more calibrated and makes it such that whenever you're ensembling predictions from different views of the same test, you get a more, let's say, precise prediction. Similar aspects of, let's say, test time adaptation can be used in other vision tasks, such as the action segmentation in videos. So if you're interested in segmenting out a video into actions, so for instance in sport videos, one of the ideal aspects you want to obtain is zero-shot ability to segment actions. So given a data set such as the one that you can see here, I don't know if you can see the, well, on the left-hand side for you, the traditional approach would be I train my model on a sufficiently incredibly large diversity of videos in such a way that if a new sport comes up, say, let's call it paddle, I'm able to segment also the actions in this video. This requires that you have seen so many different sports in training that you can exploit zero-shot abilities, which is typically difficult to achieve. Okay, so a different perspective is that instead of using multimodal models to support the segmentation aspects. Let me check the time. Yes, I still have time. And the way this is done is essentially, and this is a big and articulated architecture, but aside from the complexity of the picture, there are basically three phases. What this architecture is trying to achieve is essentially having a frame level, what you can see on the top, a frame level prediction of the actions being portrayed there, which you can obtain from any pre-trained multimodal foundational visual language model. Okay. At the same time, bottom, you can have a description for the full video, and then you have an interaction between those two modalities that try to sort of agree on what's going on within the whole video and within the single frames. So again, this idea that is becoming quite common and widespread of the fact that in order to achieve prediction for out-of-distribution stuff, what you need to do is instantiate multiple agents, have them work the problem from different angles, and force them to come to an agreement. That's essentially what you get in there, okay? And the third phase is the phase in which you sort of adapt some model parameters. When you see the freezing, they are they are frozen. When you see the fire, means that they are adapted. Adapt them to come to a decision about how to segment the video into reasonable segments that contain a single type of action. use it to predict, and then throw away the trained parameters, restart them from scratch, and go on with another video. So this is the idea. There is training, indeed, but it's just test time adaptation, because that training is only local to the prediction and then is thrown away. Other things with which you can have fun is more foundational. So if you're interested into online continual learning, so you're under the assumption that you actually have a model and you want to trade it online as samples come by, and then you throw away the sample, you would like to have a learning mechanism, some sort of, or if you want, a bit more specifically, an optimization algorithm that makes sure that the parameters that you're finding after the adaptation step can sort of trade adequately between the new information being introduced and the old information being erased. Now, the interesting piece of information here is the fact that the Fisher information matrix gives you a nice vision about what's the curvature of the loss and what's the structure in the parameter space. And turns out that you can use that Fisher information matrix, and specifically the Kullback-Leibler divergence defined on the Fisher information matrix, to define an update rule, the one that you see above there, that somehow trades between what you see at the top right with the delta is the gradients. That's just the gradients on the current sample, okay, NT, and on the small mini batch of experiences that I maintain from the past, okay? And then there is the second order optimization term, the Fisher matrix here, marked as F, and there is a Fisher matrix connected with a new sample and a Fisher matrix connected with the distribution from the old task. And lambda is trading between the two, okay? So this rule that you can derive essentially by differentiating a loss that is the sum of two Kullback-Leibler divergence, okay? It's a loss that by nature separates and allows to introduce a new piece of information by modifying only that portion of the, say, weight subspace that has less interference with the knowledge, okay? I know I'm oversimplifying a lot in this. Very quickly, I have 4 minutes left, so another 2 shots. This is going to be very quick. What if you are in a multi-agent scenario? In a multi-agent scenario, you expect your agents being distributed perhaps physically in different places to learn separately, okay, and adapt their model. Can we get to a common shared, let's say, knowledge between them? Yes, I mean, that's what in partly federated learning does. Here we push further this aspect because we make no assumption about they being about the same distribution, but rather we want they being about tasks from the same distribution, but rather we want a mechanism that allows to fuse this information all together into a single model. How you do that? Essentially, you do it with a knowledge distillation mechanism. And the key thing is that in this paper, they show that you don't need to have any data, to maintain any data, to transfer knowledge from a remote agent to a centralized model to do the knowledge distillation. You can use whatever random data you generate, like an image that you save for your, let's say, for your own reasons, that is completely disconnected from the task on which the models have been trained. Use it to generate, let's say, the gradients for the distillation phase, and that will actually lead to a proper fusion of information, transfer of information from the learning agents to the other ones. Just to conclude, if you want to have fun with swarms, which are very loosely coupled collectives of agents, you can imagine a very dynamic swarm intelligence task in which my elements of the swarm are robots that pick up stuff, boxes, and move them around. And you can throw at them different tasks through time, and you want to check if they are able to learn new things. That's good. I mean, evolutionary agents are typically good at picking up new tasks. But what is really not clear is if they retain the ability to solve the previous ones. Okay, that's what we tested. And what it shows is that evolution is nice, because while you can have forgetting at the level of the most proficient, some of the most proficient agents, so some agents become very proficient at solving the current task and forget how to solve the previous one. Overall, the population kind of retains a population-level memory of the previous task. So evolutionary learning is somehow more robust than let's say, neural intelligence with respect to forgetting. And that's quite an interesting insight that could be brought about. Just to conclude, part of the activity of this, let's say, transversal project is that has been at the community level. We have been hosting last year in summer the COLAS, the Conference on Lifelong Learning Agent, the first time that it left Montreal to come to Pisa, and it was a nice and interesting shared effort by the Italian lifelong learning community, so kudos. And the other thing is one thing that in the future you will see that is at the end of this month in Siena, a summer school on learning, well, a spring school on learning over time, which has a fantastic parterre of lecturers, and a good deal of that school contains topics that relate with the lifelong learning topic. And that's essentially it. Sorry if I went over time. That's for you to shoot a picture. No, it's 20 minutes exactly. To shoot a picture of the papers if you're interested into it. Thanks a lot. I don't know if we have time.
I think we can have a time for one quick question. Oscar?
Self for the next transversal project. I think now it's really the moment to say. So what about this transversal research could be really impactful in the next years, narrowing or enlarging or changing? What is your vision? Is there something that we put now on the table and say, okay, now so far we have there was a game, now the game is serious?
Yeah, that's a very good question, Oscar. Thanks a lot. I think I have a very concrete one and possibly a more prospective one. The very concrete one is connected with the fact that we are starting to develop and to deploy and to probably not maintain yet foundation models that support applications everywhere. So essentially AI is part of code and systems. Now is the time in which we develop the full software engineering pipeline to maintain, monitor the performance of those stuff, and decide, understand when they go out of distribution, where they are uncalibrated. So I think in all of this, in the fact that from now onwards, AI would actually be deployed and things will start to go not the best way possible, now it's the time in which we start using and we start deploying and we start making more concrete and more engineered these methods to support the actual deployment of these, at least of those softwares that are based on foundation models. Because expecting that once I've trained the foundation models, it will work forever in a real world is completely unrealistic. I mean, that is perfect and untouchable. I don't believe that. That's one thing. More prospectively, I think it's time that we start building a different vision other than foundation models for AI, and that's something I keep vouching for. That is more focused on specialized agents, specialized architectures, efficient architectures, supported by different forms of hardware. I don't want to die an NVIDIAN, so I want something different. And I can see some movements both in the scientific community as well as in the industry. There are interesting activities in terms of developing also computing support for that. And that again is where efficient architecture, efficient learning models efficient learning algorithms that can learn over time can play a role, but this is a 10 to 20 years battle rather than a short time one, I think.
Thank you so much, Davide. Thanks again. And we can Now move to our next speaker, which is Professor Roberto Navigli. Joining is not on the stage because he's joining us from Geneva, where Roberto is actually participating to a conference and probably is giving the fourth talk today or something like that, if I missed the count. Roberto is one of the two coordinators together with Rita Chiara of the transversal project on large vision and language models. And in particular, he is the coordinator for this big project about developing a family of large language models for the Italian language, which is called Minerva. Can you hear me, Roberto?
Yes, perfectly. It's a bit distant, but it's fine.
Thank you. So the stage is yours. I just introduced you, so you can freely start with your presentation as soon as you can.
Yes, okay. Just give me 1 second, because I think I forgot. I'm sorry about that, but it's... This is the last minute, you know. Okay, just
Take your time. You're trying to understand how to share your screen?
No, I have actually realized that I am using the wrong slides. But I'm just give me 10 seconds and I will be there. Yes, here we are. Okay, I'm ready. Apologies. Okay, share.
No problem.
Okay, you should be able to see my screen now. Okay, can you hear me? You see the screen?
Yes.
Okay, so thanks a lot for this invitation and sorry for not being there. I would have really loved to. Unfortunately, I'm in Geneva. And so actually, yeah. So I'm giving the same presentation I gave here. So that's why I forgot to update this, sorry. But it's focused on an outcome of the FAIR project, which is the Minerva LLM family, but it's also talking about a couple of applications that are actually follow-ups. And so in a sense, they also fall outside the scope of the project, but I think that's interesting because basically it gives it gives an idea of how easy it is to build applications, interesting applications on top of the outcome of, in this case, one of the outcomes of the transversal project in the FAIR project. I would start from a key thing that I guess many of you already know, but it's very important, especially now that many different players try to boast their ability of creating models, etc., to just understand where LLMs can fall, basically. And so starting from closed models, the ones we all know, like GPT-4o, Claude, Gemini, etc., to actually the most popular set of models, the open weight ones. And so these include Llama, Mistral, Phi, Gemma, Quen, and many others. These are not open source. They are open weight. So it's very important because we can download them, but we cannot replicate them because we don't have all the information starting from the data that they used to recreate them. And finally, we have a few open models like Olmo, OpenElm, and Minerva, which are open source. So I can reproduce the whole process. I know I have links to the data, so potentially I can download this data again, which is an effort, but it's reproducible, and we can recreate the model. So I wanted to start from this point because it's actually one of the motivations for the Minerva project. And so what makes pre-training a new LLM hard? Well, of course, starting from a huge text corpus, this is one of the hardest things, especially when we move to another language like Italian. In English, we have a lot of text, but in Italian, we have some text and not so much if we really want to scale to tens of billion parameters. Then, of course, we need a huge neural network. We need HPC, and we were privileged to use the Leonardo HPC infrastructure. And this allowed us to create multiple base models, different sizes from some 100 million parameters to 1 billion and 3 billion parameters, and also 7 billion parameters. And then more recently, we worked on instruction tuning and alignment. And again, here, one of the biggest issues was the data. Which data do we have in Italian that we can use to instruction tune and to align the model? Very little. And this allowed us to create the instruct model, the 7 billion instruct model for Minerva. So why should we make such an exercise? I think it's important today when we see this flourishing of LLMs with all languages, with all from all countries, etc., many countries, etc., etc. And so the main reason, the first thing was to be open. And that's actually what I already mentioned, both training data and process documented. And then controllable. Retraining from scratch compared to building on top of models created by big tech companies it makes a big difference because it allows to intervene in each phase. Having an instruction-tuned model, which is something that we could do only last November, was possible thanks to creating 600,000 instructions in Italian on a wide variety of activities. So this is questions, requests, translations, conversations, and so on, and even coding. But the point is, we are not that happy because this data was created in a number of ways, starting from translation till manual curation, but it doesn't cover the huge variety of instructions that state-of-the-art, closed-source LLMs can cover. And we don't have that data. So we don't know exactly which instructions they were instructed with. One result, actually, I'm very proud of is the safety awareness of Minerva. And this actually was one of the latest additions. We worked on this in September and October. When we realized that actually even an instruct model would not be able to avoid producing content that falls into discrimination, illegal substances, crime, sexual themes, self-harm, weapons, and so generating sensitive content that not everyone maybe is happy about. And we did this by, in part, translating from English, in part, quite a substantial part, creating data from scratch in Italian. Overall, the 7 billion Minerva model was trained with 2.5 trillion tokens, equivalent to 15 million books. It contains 7.4 billion parameters, more than 20,000 safety instructions, and we used 300,000 GPU hours for training. And we also created a benchmark with 18 tasks for Italian evaluation. It's available, so it can be downloaded, it can be studied. There's a paper we presented at Click. We're about to release a much longer white paper. And there's also a chatbot that is based on the Minerva Instruct version that you can test here at minerva-llm.org. It's more than 12 months of intense work, thanks to 15 people. So I'm very grateful, of course, to all these people. Researchers, PhD students, NLP engineers, not only from Sapienza, but at later stages and here now in 2025 from Bubblescape, my spin-off company, and also in collaboration with Cineca and in part with NVIDIA. So again, why is this effort important? First, because it's an LLM pre-trained from scratch created by a public university as a public effort. This is very important. We all know that. Creating public know-how is strategic. And these people now have this experience and they can build on top of it. They can share knowledge themselves, etc., etc. And also, thanks to its open nature, it can be the basis for PA projects, for example. As I said, we also released the first big Italian benchmark with 18 tasks, and it's a term of comparison for future models. This is the roadmap. So basically, we are here. We started what I called Laboratorio Minerva as a reference point for LLMs, and we are now working on larger 14 to 12, 20 billion parameter model that ideally will also be multimodal and include more languages. There are four main directions I would like to very, very quickly talk about: evaluation, factuality, safety, and graph RAG. For evaluation, as I mentioned, we created this ETA benchmark that contains 18 tasks. A bit more than half of these tasks obtained by translating English data sets, and the remaining data obtained by adapting data sets that were written natively in Italian, but with a classification, originally with a classification goal. So we just adapted those data to become generative tasks. And so those questions were framed as we started from a classification that we created with the alert work. That was a joint work with other universities and also with Bubblescape, which included 6 main categories: hate speech, suicide, guns, regulated or controlled substances, sexual content, and criminal planning. And then we also identified a set of fine-grained categories, and we created tens of thousands of instructions, requests in all these fine-grained categories. And as a result of this, we could evaluate several different models, including, of course, the top ones like GPT-4 or Mistral and Llama 3, etc., and identify those that were safer. And then we also used this data curated in Italian, because this was started in English, to safe-tune Minerva. Then 2 quick demos I would like to show are the fact-checking use case. With Bubblescape, what we did was to build on top of our results to create a system that queries the web, given a certain claim or a certain sentence. Of course, this can be scaled to a whole document, but for the demo, basically you have a claim to verify. And what we do is we search the web, we obtain results. These results are classified with a natural language inference model. And then we produce explanations for why this classification is a rejection of the claim or a support of the claim, as you can see in red and the green respectively. And finally, we produce a summary of the classification. So for example, State Department plans to spend $400 million on Tesla Cybertrucks, and this has been classified as false, with a summary of why the sources that we retrieved reject this claim, and actually one that comes from earlier news where this was actually stated and then more recently removed. Like this name of Tesla was removed from the State Department website. And so in a sense, this was a support, but it's still mentioned in the summary. Actually, I have another example that I wanted to show on the fly that I created this morning. Poutine n'a pas envahi l'Ukraine, which means, as you can guess, Putin didn't invade Ukraine. And then if we query this, now I don't know, wait, there's something with the website that didn't reload them. I don't know what's going on. It's a demo effect. Okay, let me reload it again so that we try again. It's not working. Okay, let me just out of curiosity just try this. Oops, just wanted to check whether it's my browser or whether the system has a problem. Okay. Save preferences. No, apparently there's an issue. Okay. Anyway, I'll skip it. It's the demo effect. Okay, then I'm also presenting another demo, which is a graph rag approach. Basically, here what we did was to take the cultural heritage catalog and build a graph rag system that basically queries this structured content ontologized through a knowledge graph. And what we did was to create a system that where you can query things like, I don't know, show the sculptures by Bernini, and what you get is this query gets transformed, this prompt gets transformed into a query, a structured query, and then as a result, the result is then transformed into natural language, including links to some of the results obtained from the query. And then there's also like the identification in case of ambiguity, like in this case, there are multiple Berninis. The system also tries to identify the most relevant one, which in this case is Bernini Gian Lorenzo. And then it asks, do you confirm that this is the author you're looking for? And then I say yes. And what I get is a list of some sculptures by Bernini. And these are, and then the links to the complete card that explains the various sculptures. Then a new conversation, I don't know, talk about the Città Ideale, the Ideal City by Luciano Laurana. And then the model tries to identify the question. And oh, yeah, now I get why it's not working. Maybe I'm not connected to the VPN. Oh, but it's working, okay. And so this is the answer. So, and then you have an explanation, a link to the a card of Luciano Laurana, pictures, explanations, connection to the catalog number, etc. And then you can continue the exploration. So I think these two examples show, in a sense, the easy, well, not easy applications, but applications that can be built on top of Minerva by, of course, having months of work, but without which it would be hard to do something that is specific to the Italian culture. Yes, of course, one could use other models, but it would make everything more, let's say, dependent on other models that are not controllable. And so that's all, basically. Now, keep calm and use LLMs as we did cum grano salis. Thanks a lot.
Thank you. Thank you very much, Roberto. Highly appreciated. A great outcome for the project.
I cannot hear very well.
You can't hear me?
If you have questions, then you need to get closer to the microphone, because otherwise I cannot hear the question. Yeah, much better now.
Can you hear me now?
Yeah. Thank you.
Okay. Great presentation. I think there is time for a quick question if anybody from the audience wants. Any? Fosca has one.
Roberto, thanks very much for the effort of doing this presentation. So this is related mostly to the last sentence that you said, use LLM but with grano salis. Now it's a moment where the push of the big companies behind the big LLM is about this multi-agent architecture, this agentification of AI-based services and applications. So how do you see this vision? And on the other side, as I'm sure you know, there has been strong positions of very, very prominent scientists, again, including Joshua Benjo, and another couple of important ones. against this vision where you lose completely the control in the design and in the validation? That's one question. The vision, and for the project for FAIR, what you would suggest? So choosing the language as a champion and putting all our effort on on this large language model.
Okay, I heard 70–80% of what you said, so I hope I can interpolate.
But you can guess, I'm sure.
Okay, I'll do my best. So I think I got the point of agentic AI. That so basically you're asking what I think about it, what's the vision, and let me first talk about the good things of it. So of course, in a sense, it makes the experience much more composable. So in a sense, we can use different agents that are more specialized, that are more controllable, in a sense. To the point that we can then replace a component more like software engineering style with another component that carries out a similar task or the same job. And so in this respect, I see it as a positive thing. I also see the concerns. And so that this would, now we are starting to see applications that can really do everything coded for you. And this is, I think, the problem, that it might get out of our control. And so, unfortunately, this goes beyond, in a sense, my expertise as computer scientist, but I see the problems, and I'm closely following the concerns that are raised. And so my point is we should, as much as possible, avoid that big entities can really supersede governments and decisions that can really affect the society. So I think that's the biggest, that's the take-home message. So we need to avoid, now we are seeing in the US, for example, that it's relatively easy for powerful people to take control. And that's yet another reason for making an additional effort in this direction, I think. I'm not sure about the second part of the question. So I understood language as a champion, but I didn't get the real gist of the question.
It's about whether you somehow agree that Minerva and the developments around it can be championed as one of the key results for FAIR, and what's your...
Well, maybe I'm not the person to ask, I don't know. Well, of course, I'm very happy that Minerva attracted a lot of interest and had some success. And also, I talked to many people, like, for example, even today, I'm talking at this data technology seminar about news media broadcasters. And everybody's interested in the philosophy behind Minerva. So the fact that it's completely open, it comes from a public body, it started from scratch. It doesn't try to oversell, in a sense, because of course there are also limits. Because if you try the system, you see that it's not ChatGPT, and we know why. It's not our fault, in a sense. There's a lot to be done. At least it shows the limits and shows the problems that are behind, but it also allows to have a model that is fully controllable, that certainly gets, I don't know, 1, 2, 3, sometimes 4 points below the state of the art, but it has different features and guarantees. So I think, I'm very happy that this is a message that is conveyed and that people are understanding.
Okay, we have another question.
I fear that the answer is no, but this just came to my mind thinking of this LLM for Italian. Is anyone trying to use LLMs to save languages that are disappearing?
You have to summarize it.
And of course, there isn't a lot of data for them, but you could take people and just have them express themselves as much as possible before they die. I don't know if this has ever been thought about, if someone is trying this, because this could be one good use, you store it all in a monster neural network of some type? I don't know. It just crossed my mind. I don't know if it's an answerable question, if anyone knows anything about this.
It's very, very distant. So, Dino, if you could summarize it, fortunately.
Non si sente questo.
No, the question by Francesca Chiaramonte is about whether anybody thought to use LLMs to save these endangered languages or disappearing languages.
That's a very interesting topic. Actually, there are a few works on this. Like I was at AAAI last week in Philadelphia. It was very interesting. There was a paper joined with the Bill and Melinda Gates Foundation on the fact that state-of-the-art large language models like GPT-4o, when tested on languages like, for example, African languages, and even popular ones, they fail if those languages are not don't have clear roots in common with European languages, like, for example, Afrikaans. And so this means that basically this superiority, this state of the art is actually not for all languages, we know that. And the issue with these languages is that unless it's a very popular language that is just neglected, like, I don't know, Swahili, other languages are actually in danger, and there's not enough data. So the main issue is that the current technology works in a way that if these languages have not much in common with all the other languages, so it's hard to implement, to obtain some transfer learning. And there's very little data. Then at this stage, we don't know exactly what we could do. And so this is a research topic, indeed. I think actually even for Italian, I don't want to say Italian is not an endangered language, of course, but even for Italian, it was hard to find all the data we needed. And now that we are scaling up, it's even harder. So this is a clear research direction. So there is some work, not that much, because of course it's hard to work to do research in this topic, given that there's very little data. And so it's an open question, and it's a very interesting one.
Thank you, Roberto. Thank you so much for
taking the time. Thanks a lot for inviting me, and again, apologies for not being there. I hope to be there soon.
No, you were fantastic in finding the time to join us for a while. Thanks again.
Thanks a lot. Ciao.
And we can proceed to the next transversal project on the legal and ethical design of trustworthy AI system. And we have Giulia Olivato. No, ho sbagliato qualcosa. Ok.
Un secondino, chiudo anche Zoom. Cosa c'è aperto?
Hello everyone, apologies for the interruption. As many others before me, I've also had quite some difficulties into the conversion from PowerPoint to Google Slides, but now we're all set, I hope. First of all, I'd like to thank very much the organization for the kind invitation. As I said, I'm Giulia Olivato from the University of Trento, and in the next 15 minutes or so, I will be talking a little bit about what we have been doing in the transversal project called Legal and Ethical Design of Trustworthy AI Systems, and especially what we are planning to do in the next months, and hopefully how this could support you. As a bit of background, the three co-PIs are Professor Carlo Casonato from the University of Trento, Professor Adriano Fabris from the University of Pisa, and Professor Giovanni Sartor from the University of Bologna. Of course, these are three very eminent academics. They're very busy, and so you're stuck with me. The scientific partners are the University of Pisa, the University of Trento, Fondazione Bruno Kessler, the University of Naples, Bari, Politecnico of Turin, and the University of Bologna and Catania. And as we have quite a lot of partners, actually in this transversal project, the coordination has had a strong role since its very start, as the necessity of achieving a legal and ethical alignment is a necessity which is horizontal and integral to many activities across different spokes. So actually we had a very strong worry about having the different participants sharing their activities so as to exploit synergies, avoid duplication, and so on and so forth. But it's not all, of course, about coordination. So we also had several meetings, both online and in person, and in which the discussion highly benefited from the diverse panel of speakers and participants, and there were opportunities for partners and other interested researchers sometimes to meet and discuss intermediate results and next steps. Actually, the various research, publication, and dissemination activities of the spokes engaged in the transversal project were carried out following convergent methods, perspectives, and thematic areas. So the word cloud on the right shows only some of the main themes which were pursued in the various research lines, such as generative AI, legal explicability, digital environments, ethical and legal assessments, risk regulation, data governance, and of course the AI Act, which seems to be ubiquitous nowadays. So as for some example, we studied with Fondazione Bruno Kessler a framework for the ethical assessment of AI-based applications with the aim of integrating it actually within the development of these AI-based applications. There was also, but these again are only some examples, a strong focus on the concept of individual and social vulnerability in the AI application, and of course a strong analysis on the AI Act and its different elements. So the structure, its risk-based approach, governance, data sets, transparency, generative AI, and so on and so forth. And of course, this morning, Elio Grande already talked to us about the common framework of ethical reference principles, which was developed by the University of Pisa. As regards some numbers on the TP1, it is, of course, a strong interdisciplinary project. We have 18 philosophers, 16 technical experts, and 24 jurists. And of course, this multidisciplinarity is really its characteristic, which is reflected in the wide range of topics represented in the scientific articles and other works which have been published under the transversal project. And also, the transversal project saw a number of activities, courses, and workshops to disseminate actually the results. As you can see, I only wrote around 60s because, as you are well aware, there is a reporting deadline coming up. So, of course, numbers are still coming in. But this is, a good estimate, probably. I would like to briefly mention an outcome we're quite happy about. which is the AI Act 101, which was a webinar series about, of course, the AI Act, to introduce it also to non-jurists. We organized it in the late spring of 2024, exploiting the diverse expertise across spokes and across domains. So we had a multidisciplinary approach, expanding the legal and policy discourse with perspectives drawn from philosophy or computer science. So we tackled broad themes of the AI Act, such as the scope and definitions, the risk-based approach, governance, and general purpose AI. We also had quite a nice online attendance and even better YouTube views, which is always good to know, you know. And indeed, while the AI Act is not the only thing to keep in mind when developing AI applications, so I'm thinking maybe about the training process, so data protection and copyright concerns, the AI Act is still certainly something to look out for, and arguably most of our legal analysis has focused on the AI Act. So I guess that many of you are familiar with this risk pyramid, which is from the AI Act, of course. So it has already been shown yesterday in Intesa Sanpaolo's intervention and also briefly this morning. It shows actually this distinction between different risk levels, each of which has its own discipline. So, and also at the bottom, we can also see the provisions for general purpose AI models. So now we're here, which means that actually only unacceptable risk AI systems, only the provisions for unacceptable risk AI systems are currently applicable, whereas the provisions for all the other risk levels are not yet applicable, which means if we look at it diachronically in the next slide, again, I'm sorry, there were some things, but now we have the PDF, so of course it's a little bit different. If we look at this diachronically, we have in July 2024, the AI Act was published. In only 1 month later, it entered into force. Now again, we are here. So last month, prohibitions and AI literacy requirements are applicable. But as you can see, there is still a long way to go, right? So you may be wondering if we are here and we have certainly a long road ahead, why should we worry now? This is because actually the AI Act affects also the design and development of AI systems and general purpose AI models, which means that it is sometimes difficult, if not impossible, to comply with ex post, which means we need to prepare. Hence, we're organizing a second edition of the webinar, so building upon the last one and delving into specific themes which are already or are soon to be applicable. So stay tuned for that. Actually, as you see, because of the AI Act's timeline, because there is this staggered application, which means that different sections of the Act become applicable later in time, there is this timeline of the AI Act. At the same time, the end of FAIR draws nearer and nearer, but still we are actually accelerating the preparation of dissemination events. And so you can, maybe you can see here that there are, yes, great, that there are future AI Act-related activities. So first, in April, May 2024, there will be this second edition of the webinar, which, again, it's about the more pressing concerns, okay? Then there will be a more in-depth AI Act conference in the summer. And then there will be this, we called it AI Impact on FAIR. So we have this project according to which we would like to understand actually how the AI Act affects fair projects. First, I would like to ask you some questions. Unfortunately, as you saw, we had kind of big technical issues, so I guess I will be doing the old style. I had prepared a VooClub presentation. I'm not sure if some of you know what this is, but I guess we can just do with a raise of hands. I'm sorry. This will require a more active participation by your side. I know that this time of the day is not really conducive to that, but it only will take a couple of minutes, I swear, not much more than that. So do not do this, because it will not work now. So first, I would like to know, how confident are you in your understanding of the AI Act? Think about it. So A, very confident, B, confident, C, not confident. Raise your hand if you think A, very confident. So you're very sure of yourself. Whoa, great. I'm very happy about this. Okay, we have two. We have a third? No. Okay. What about B, confident? Quite a nice raise of hands. Really happy about this. Okay. Not confident. Well, I mean, it's all the others. Okay. Then, in your opinion, how much the AI Act may affect your work? A, a lot. B, I do not know. I mean, who knows? C, not at all. What about A? Oh, A, not a lot. Okay. B, I do not know. Okay, that's the majority here. C, not at all. I guess, yeah. Sure. You're actually, yeah, you will see. Just wait a second. Okay, so we're almost there, I promise. In your line of work, if a question arises regarding the AI Act, or if a question should arise, you know, maybe it hasn't happened yet, but imagine it does happen. So you have a question on the AI Act, who would you contact? A, Google or ChatGPT. B, legal office, I mean, of the one of your university or research center. C, legal partners. D, I do not know. Think about it for a couple of seconds. There are no wrong answers, you know. So what about A? I do not judge. Okay. B, the legal office of the university. Okay, some raise of hands. C, legal partners, if you have any. Okay, great. That's a totally self-serving question. Sure. D, I do not know. I mean, it's comprehensible. Yeah.
I think that the list misses one point.
Yes.
Read directly the text of AI.
Yes, but it's very lengthy. So So I understand one can get discouraged. That's all I say. Well, kudos. And last question as well. Oh, that's okay. Yes. About the AI Act risk classification. Okay. I'm sorry. Regarding these different sectors, how do you feel about them? Do you think that the deployment of AI applications within this context may raise some risks, possibly pose some harms, or is it totally okay, no risk or very low risk? So I guess in this case we can do a raise of hands. So raise your hand only if you think that the deployment in this context may pose some issues. So what about education? Yes, okay. Healthcare, that's an easy one. Okay. Manufacturing and supply chain. Still, could happen, you know. There's still safety involved. Law enforcement. Okay. Marketing. Entertainment and media. Yeah, it depends on the application, I know. Finance and banking. Okay. Human resources and recruitment. Yeah, sure. Agriculture. No. Maybe. Yeah, maybe, you know, there may be environmental risks if we use too many pesticides, for instance. Yeah, sure. Yeah. What about access to public administration services? Yes, of course. And the legal sector? And with this, I mean both for lawyers and judges, like the use of AI in tribunals, in courts. Yeah.
Less than law enforcement, but yes.
Yes, I guess there is a good. Yeah, actually, I highlighted the sectors in which, according to the AI Act, are considered high risk. The legal sector is dotted because, yeah, it's more use cases based. It's only as regards its use in courts, basically not really by lawyers. So, thank you for indulging me, first of all. Now, actually, I would wrap up my presentation and actually explaining a little bit better to you why we did what we just did. Our next project is actually the one called AI Impact on FAIR. Our goal will be that of mapping the risk categorization of current FAIR projects, as well as, I mean, consecutively, as we map the project, we also map the risk categorization and therefore the applicable discipline, also with regard to the possibility of applying some of the several exceptions within the AI Act with the aim, in perspective, I know it's kind of ambitious and future-looking, of understanding not only the state of the art of the AI Act's impact on research, as we could utilize the FAIR as a kind of reflection on overall Italian research, and also possibly to identify new research lines. Basically understanding actually which are the ICT research lines which could be more impacted by the AI Act, and hence preemptively develop maybe guidelines to help you with that specific research line. Because of course, as we all know, now you're all bored to hear about this, the AI Act is horizontal, so it's very broad, and actually there is a true difficulty also because it interacts with a true and ever-growing ecosystem of other regulations. And actually, with the AI Act being finalized and now starting to be applied, there is a lot of talk regarding the dichotomy between the regulation and research and innovation. However, this discourse is always very abstract and high level. As we saw earlier, we actually do not know how much the AI Act will impact research. And this is what, with this project, we are trying to do, you know, just to understand in reality, using FAIR projects as a reflection of the overall research lines, actually what the impact could be, also because it is not true that every AI application will be, especially in research, because we have many exceptions for research, will be regulated by the AI Act, and in fact, many will not be. For example, in these couple of days, I have seen a lot of your presentations, and many of you are working on specific methods and technique, which may be later on utilized to be applied in AI systems which are deployed in a specific context. Because of course, as we saw, the AI Act as regards the risk categorization is actually very much sector and use cases based. And so I understand that many of you may not be directly impacted. Nevertheless, if still you could please fill this questionnaire. This will be very helpful, also because it will help us understand actually how many projects will not be impacted by the AI Act. There is no prior knowledge required about the AI Act, and it's quite fast to fill out, as after the first question, the next question changes according to the previous answer. So it really depends on what you choose. So thank you so much for your attention. I hope I did not overtime. So thank you.
Thank you very much. Very interesting. I think we should now proceed to the final presentation and postpone the question to Giulia Olivato during the break. We now have Fosca Giannotti with the transversal project on the third.
Okay, so this is one of the other transversal project. It's about learning and reasoning to assist decision-making at multiple scales. So the coordinator of this task, of this transversal project, are Bruno Lepri of FBK and Luca Pappalardo, but they are both busy, so I will do the presentation on their side. So, and as you see, this is the organization of the transversal project. That's one which is, it involves, some of them both in the area of human and society, both in the area of robustness and in sustainability. So the goal of the project was, let me see if I have, is to study the methods, methodologies, and impacts of learning and reasoning and decision making at scale. At scale means that the focus of this transversal project is to have both the effort to aggregate the efforts that we are doing as researchers at the level of human-machine cooperation. Collaboration at an individual level, at the level of community, and at the level of society. So now I will give you an idea of what the methods that are developed in the various spokes. But there is a premises, an excusatio, that while we had a nice vision of this transversal project, but we just met once and with a lot of big dreams, and then all of us were indeed very much on the individual, on the spoke problems, and not we could really have this transversal vision. So in some sense, with respect to the other presentation, the organization, the interspoke work has been very small, but the intentions are good. In some sense, we have a good individual, I mean intraspoke good results. We need interspoke activities. So one is the human in the loop paradigms. We saw many things in this presentation of this spoke here. So so the focus is on explanations, and then in explanations we saw in this spoke explanations in a variety of different flavors and we have developed architecture, we have developed algorithms which tackle specific topics, specific learning tasks, learning challenges, like explaining in the case of federated, explaining with different forms of high-level form of explanation from rules, counter rules, factual, fuzzy rules, and what else. So we are exploring all the flavors or explainable AI, so post-hoc, global, and what else. Also, we have, thanks to the synergy of various projects, we start to, so we have a platform, libraries, and some that might be a sort of champions to be developed, further developed and applied together. So there is one of the other topic in this work pack, in this spoke, it's this idea of also hybrid decision making. But all those things we have already heard. Another component in this spoke that we are pursuing is this at a scale. So describing, observing the dynamic of a socio-technical complex system, trying to being capable also of capturing the co-evolution of a system which is based on this collaboration so at societal level of artificial agents which collaborates with humans. So analyzing this human feedback loop, it's one of the issues, and also doing this in many different contexts. We saw the decentralized learning as an important. So there is always those two elements. So which kind of learning and inference behind the system that has to be decentralized, we have also to do at the edge. And what is the feedback loop at level of users, societal level. So we are doing some experiments like in the urban environment, or also in the area of social media experiments. So another issues which is brought in this transversal project that it's the contribution of Spoke 2. It's about developing theoretical methodological foundation for hybrid human-machine intelligence, particularly when such collaboration is based on large language model. Now all of us are in some with some different flavors and nuances, trying to see the impact of using extensively this new form of agents which may interact. So we were talking prima. So a large language model that simulates personas. We just so you see there are recurrent topics, and I think that this is also the moment also to try to synthesize. So large language model. There is one interesting experiment. A large language model as support in clinical decision making. There are other experiments, a large language model in support of public administration. Those are responsible chatbot. So that try to combine is a sort of transversal project topic. So what should be the design principle of a chatbot that in principle might not be high risk because it's only maybe transparencies, it's not considered a high risk, but when it is based on large language model, there might be other risks that emerge. That may be not damages, but at least might be damages for the administration. If you insert some fake things in this debate with the person and the machine. So that's okay. Again, explainability in all the formats. So it's as a algorithmic recourse. And then in the spoke of Spoke 6, it's symbiotic artificial intelligence. There, the focus is on the design of symbiotic artificial intelligence system, and what should be at the design, what should be the design principle, and also the implementation and deployment principles for moving from algorithmic center to a human-centered approach. And also here, explainable AI understandability is one important, an important focus. And also in this work pack, in this spoke 6, that is synergistic, which is the one among the spokes, the one which has really more synergies with what we are doing in spoke 1. It's they are doing interesting application in health of human AI interaction paradigm in different applications in health. And okay, so they are the group working in spoke 6. They are their topic is human-computer interactions. So they are strongly inserting this, the competences of human-computer interactions in the design of an AI-based system. And also they are also collaborating with cognitive people. So that's it. So in some sense, there are plenty of research, plenty of overlapping research, but still we don't have, I would say, a common narrative, and also we haven't yet really one champion that we have selected to be a sort of, a common effort on doing this. And this is the sort of interest of doing this. Okay, fuzziness, it's another issue which is all over, working with different forms of managing, representing uncertainty. And what else? I want to say something about, okay, there are several applications of explainable AI. Okay, and also here in this spoke, in the spoke this is spoke 8, the way they see Bologna. It's Bologna, which is pervasive artificial intelligence. So again, there is the focus on the social dimension of artificial intelligence and impact of large language model based on chatbot and human dialogue. So that's another important. So there are overlaps. So there are plenty of activities which we are pursuing separately that might merge in a common vision, and that might be a goal for the next months. But there are also overlaps with other transversal projects, particularly the trustworthy transversal project, and also the transversal project 1. Okay, that's it. And then, so the impact, the study of the impact that they are doing in the spoken Bologna, it's about the impact in education, which kind of awareness tools could be provided when we plan to insert large language model in education systems. That's an important issues. There is in education an enormous activities for using large language model from the university. So from imaging the automatic and personalized tutor that does the synthesize the information from the books which has been assigned by the teacher. And so having a personalized teaching to the very important education tools that we may design for people with diverse needs. So there is also research that where really the language of that this foundation model can provide, the types of interactions might be really an opportunity. Okay, and then, so what next? So I ask myself the question that I ask to the others, what next? So it's really, so we are scattered and overlapping research activities, all very, very centered on this idea of a human-machine collaboration and the effect. There are those two dimensions, and the impact of the coevolution of a ecosystem which is powered by AI. So there are those two topics. At a different level, we are all playing with research around that, but still we don't have a common narrative, and that's a topic. And of course, responsible generative AI, it's the elements that it's the new elements in our agenda that we have to consider. Okay, so that's it. If you have questions, write to Luca Pappalardo.
Thank you so much, Fosca. I would like actually to thank all the speakers for this transversal project session. So Fosca Giannotti, Giulia Olivato, Roberto Navigli, who joined online, and Davide Bacciu. I think they are portraying an effort which is far from trivial, right? It's actually complicated because FAIR is a huge project, which is, we are a huge spoke in Pisa, and there are other 9 spokes. Really a wave of researchers that are working on topics, so trying to coordinate in such a short period of time the work of so many people in so many large projects that are also scattered across the country. It's really something which is both beneficial and also difficult to do. So thanks very much for your efforts for this. And now we can switch to the session that is dedicated to our young researchers. As you have seen, actually, many, I would say most, of the contribution from the different work packages of the spoke were actually presented by young people, early stage researchers, postdocs, or PhD students. But still, not all of them had the chance to speak. And also, disregarding whether they already spoke or not, we wanted to have a session where some flashlight presentation, they can quickly tell us what they're doing and what they perceive as the future of both their own work, their own research, but also what they perceive as an important view of the research for us as a community, what they perceive as the most interesting topics to come in human-centered AI in this very wide sense that we are somehow understanding the term in this room. So I would like to, if Mattia can help me, let's thank the speaker for the transversal session once again. We will, I don't know if there is room for, or why don't you come all in this area so we can... Some can sit, and the others will stand up, including myself. You start.
Yeah.
Okay.
So, hello everyone. If you were so lucky not to get to know me for the KPIs of the project, that is me. I'm Mattia Sezzo. I'm a junior researcher and RTDA here at the Computer Science Department of the University of Pisa. And for me and for all of us, we have tried to have a very straightforward presentation. So, as Dino mentioned, just 3 slides. Who we are, what we work on, and what we are going to hopefully do in the future, contratti di ricerca and other open positions allowing. So, as you may have anticipated, I work on explainable AI. mainly on explainable AI by design, so mainly on decision trees, so novel algorithms for inducing decision trees, and also understanding exactly when it is proper to use a decision tree, because sometimes it can be even better than using a neural network. And another open area of research that I'm working on are meso explanations. So you have seen in the work package 1 that we usually reason in either explanations which are local or are global, but a wide area of research which is, at least for now, a bit of a niche area is that of meso explanations. Thus, explanations which work for groups rather than single instances or all the instances that you have on our data set. And at the same time, I'm also interested in human AI collaboration. And so I'm mostly interested in so-called hybrid models, so models which are able to abstain, to defer to other, maybe better models, or directly to humans. And this, of course, has a lot to do with the work packages 1 and 2. And as for my look forward, what I would like to work on is still working on explainable models, but not just inducing them as we have been doing up until now with carefully researched algorithms, but maybe create some neurosymbolic models which are able to induce directly these explainable models. And this also, of course, goes both for the explainable models and for the hybrid models themselves. That is, models which are, once again, able to defer, to reject, but also tell us why this is the case. And for my vision on human-centered AI, once again, as you may have seen from my handling of the KPIs, I have very strong opinions. The first one is on the so-called Turing test. We have thought about AIs as intelligent if they can simply trick us into thinking that they are human, but this is a so-called weak hypothesis on intelligence. What is a stronger one, and which was introduced, I think, around the 70s, was a stronger hypothesis, which was the one based on the idea of the Chinese room. For those of you who don't know it, a Chinese room is simply a room in which we put a person which has a Chinese to English dictionary. We talk to them in Chinese, they simply translate to English, and they solve whatever task we give them, and they translate back to Chinese. And the idea behind this is that they don't understand what they are doing, and thus, much like AI models, they are not really thinking and understanding. And with this slide from ADM, I would leave the floor to the next speaker.
Thank you, Mattia. I am Domenico Tortorella, a postdoc researcher assegnista di ricerca for the Italian speakers here at the Department of Computer Science at the University of Pisa. I'm working within machine learning, computational intelligence, and machine learning group led by Professor Micheli. You can get in touch, learn more about me on my personal website, linked here. So, what I'm working on? Well, my main line of research is efficient models for deep learning on graphs. When we talk about efficiency, some of you may think about optimization tricks, dedicated algorithm accelerator, something like that. Well, I'm not interested in this kind of line, but my effort is to develop models that are efficient by design. That are both suitable for static and dynamic graph data. So one example of such class of models is models based on reservoir computing, where we do not train the neural module responsible for producing graph representation, but we simply rely on initialization condition given us by theoretical investigation on the class of models. And this investigation on core factors that contribute to graph learning model effectiveness is the main driving factor that enable us to design efficient models. For example, in my research line, I've discovered the crucial role played by the Lipschitz constant in deep neural network models, both for graphs and for sequential data, which is usually the more contributing factor to efficiency than any training we could perform on those. And this work is carried on within the work package 3.3 on complex data, but we also been collaborating with other work packages such as the one led by Sebastiani and Morea from ISTI on network quantification. So what do I see in my future and in the future of human-centered AI? Well, so far my investigation centered on the effective factors, that is an investigation that has been machine-centered. For example, conditional Lipschitz constant models and so on. And I'm driving to move on from this machine-centered investigation to more human-centered investigation, where we also try to develop interpretation and explanation on models for graph learning. This is a research direction I've been working on with Marco Podda and Michele Fontanesi, and we're investigating native basis on models and explanation of models to drive us more effective AI for human application, human interpretation. So my vision is that efficient and explainable learning models will democratize access to AI. So instead of big corporations able to train huge models or huge set of data by home-use hardware, we will be able to harness the power of AI in the hands of even simple users on their own laptops and PCs. So, as to quote the philosopher Protagoras, Panton crematon metron est anthropos. So, the human is the measure, the utility factor that should drive us our actions. So, thank you. Sending the word to the next speaker.
Good evening to everyone. My name is Elisa, and I am a PhD student in AI for Society at the Department of Computer Science here in Pisa. I have a master's degree in archaeology, so at the moment I am a part of a great team that is called MappaLab at the Department of Civilization and Forms of Knowledge. As a part of FAIR project, I contributed to the working group number 7, which deals with case studies, and I apply artificial intelligence techniques to environmental archaeology. In particular, my PhD project is about scientifically reconstruct the ancient vegetation environment starting from pollen data using AI techniques. Regarding looking ahead, on my research, I know it's mantra, but I see a more collaboration between experts from different fields to enhance the reliability of the output and increase the scientific feedback of our research. And about more generally, I think that there is a need to make the use of AI more aware, also for the broader public outside the academia world.
Hello to everyone. I'm Lorenzo Fiaschi, postdoctoral researcher at the Department of Information Engineering in Pisa. And my background is on computer science, computer engineering, artificial intelligence, all mainly applied to enforce priorities in learning. Okay. Currently, I'm working in the work package number 2, task number 3. And as I told you, the idea is to induce some knowledge, a priori knowledge we have on the agent we want to craft, to develop, since the very beginning, at the very level of the algorithm, or even at the level of the numbers. So the idea is that, okay, I want to train this, but I want to train this in such a way that it will arrive at a certain point. Okay, if you have a certain amount of parameters, you have a limited amount capability of learning. So I want that my learning capability is split in several tasks, and these tasks must be achieved with a certain level of priority. Okay, your amount of capability is limited, and this allocation must be realized in a smart way. For instance, you want to prioritize fairness, equity, robustness of your algorithm over the mere performance, okay? For instance, just to make some examples. So my research goal at the moment is to apply some recently developed prioritized multi-objective deep neural networks. And when I say multi-objective and prioritize, I mean that my learning, the learning of my network, of course, is made in such a way that the gradient of each network is not conflicting with each other, if of course the gradient is of a function which have a smaller, less important, okay, priority or interest. In particular, I'm currently looking at reinforcement learning application in autonomous driving settings and in deep learning tasks for hierarchical classification and capability of abstention. So for instance, again, as I told you yesterday, if you see a novel sample you never saw and experienced during training, you want to abstain on that, not just try to give a judgment and abstain on data you have seen during training. This is a priority, a prioritized task, of course. What's the quality of the learning? If you find a new topic, a new image, and say, oh, that's a cat, and it's a train, okay? What your algorithm is learning about being a cat, being a dog, or whatever, okay? So there's a priority in life. My vision is that this capability of naturally implement and induce priorities in the learning can be coupled with a lot of application and industry-oriented interests to enforce some guarantees we are quite interested into, okay? Like, as I told you before, a reliable AI or an explainable AI. We could think about the explainability of a model could be prioritized over the mere performance. Just giving you ideas because this topic is at the very beginning. I see a future for this, but there are a lot of suggestions. Like we talked before, and I think I conclude, there was a guy who told me, okay, but you may have data that are sometimes more important than others, or data that be more important for a certain task than another, okay? We could think about this. We could think about using priorities to enforce and to simplify the learning. Thank you a lot.
I have to positionize the microphone. Hello, everybody. Okay, so my name is Francesco Giannini. I'm a postdoctoral researcher at Scuola Normale Superiore. And so my main research activities concern different fields, but that are very well connected, at least according to me. The first point is about neural symbolic AI. That is also the topic of my talk of yesterday. And the idea in this field is that you have, like also human have, according to my opinion, two different components to make together, no? To to combine. And one is a neural part that is also the one that is responsible in us for perception, for instincts, for rapid decisions, like thinking fast, no? The other one is symbolic AI that often is used to provide explanations, interpretability, to reason about a problem and to try to develop a solution that is somehow, let's say, rational, no? So the famous thinking slow paradigm. So combining these two paradigms is actually something that I think can be very useful for the community and something that has been investigated a lot, quite a lot in these years, but we're not very convinced about the current solution. So maybe this new wave of AI methodologies can actually provide new insights on how to do that in a more feasible way that could be actually used to realize a sort of AGI, but I don't know, just talking. So this is one point. So as I was saying, the explainability part is related to the symbolic way we can work with AI systems. And in particular, explainable AI has some issues right now, also in terms of foundation, since it's not clear also what is an explanation and how we want to measure the quality of explanations from different perspectives. There are some works in this direction, but a unified formulation is probably missing. So also thanks to my background in mathematics, I'm trying to work on this to provide a formulation that can be at least accepted somehow. The last point that I want to mention is the role of the human in all of this. So humans is the main receiver of our work, we hope so. So in the sense, what we are doing as AI researchers has to be useful for humans. So involving human in the loop is something that is very important, and you also listen about this from different talks in these days. So what I'd like to do is to combine my work on neurosymbolic AI with humans involved directly into the process to, let's say, both defer or abstain or have a feedback loop using the human inside it. And for this reason, my works is main on the work pages 1 and 2. Looking at the future, so the idea is to continue on these research lines and trying to get something even better. So trying to rely on efficient interpretable neurosymbolic systems, so something that can be applied in real-world scenarios and has some nice properties like being efficient, being scalable, being interpretable, something that we need to well-define and then try to get the better out of it. And so another thing that is very important that currently is missing probably is the role, again, of the human inside the explanation AI scenario. So these explanations are for who? So who should enjoy these explanations, no? So also the user profiles need to be involved more in our studies. My vision is very naive. I don't know. I'm just looking what actually the society and the world is going. And so I think that for sure in the next years there will be more large language models studies. So my hope is that these models can actually provide some benefits. So trying to, let's say, develop more reliable large language models will be one of the most goals of our work. So thank you.
Hello everybody, I'm Claudio Giovannoni. I'm a second year PhD student for the PhD in AI for Society. I mainly work from Florence, but you can find me usually in the KDD lab on Tuesday if you are interested in like working together, having a chat. What do? I work with explainable AI topics, so as was already said, solutions to interpret black boxes. And also with multimodal learning. So the idea is to employ different data modalities to not only, such as maybe text, images, and so on together to improve performance, but also to create more deeper level of explanations through this multimodality setting. So what is my research goals in 1 or 2 years is to continue my PhD research project, which is to create a system which creates a fusion of multimodal solutions with explainable AI, so to create a system which is able to personalize the explanations provided by the user following the user's profile, so its attitude, its domain expertise, and its preferences, which are specific to single users. And to also use this multimodal learning to improve the performance of the model. So my idea of and vision of human AI is to create these more transparent solutions in order to foster adoption and trust of the AI systems, not as a substitute for human decision making, but as support, as social support systems. Thank you very much.
So hi everybody, my name is Samuele Sabella. I work at ET CNR in the Ubiquitous Internet Group, and this is my first year as a PhD student here. So what I do, I study mostly decentralized learning and federated learning, and I'm currently involved in data poisoning and studying the robustness of decentralized solutions. As I spoke this morning, and my current research line is taking a decentralized systems, inject some noise in some nodes, and see what happens. And I'm currently working on the working package number 5. In the next years, what I'm planning to do is basically starting to work and study mostly on the connections and the interactions between generative AI and mostly image generators, but also maybe LLMs, and the decentralized learning paradigm, where we have many nodes which share the models and try to model merge to globally achieve a better performance. Also there is the study of how do you train an inference, maybe on the edge, but on resource-constrained device in these decentralized frameworks. About the vision in the following years, I think there is a lot of concern about privacy and how to enhance the privacy and how to avoid tiding with the big tech infrastructures like Google, S3, and all that, and all those giants. So by trying to regain the control of our data, trying to mostly train locally, and then share what we have learned to other devices to globally come to a better solution. So, thank you.
Good evening. I'm Matteo Gregorini. I'm a third-year PhD student for the National PhD in AI for Society. I'm currently working both in the University of Pisa and at the IIT at the CNR. I'm in the Ubiquitous Internet Group, and I'm currently in the working package 4. My main research issue is causal-aware artificial intelligence. Right now, I'm working on automated causal discovery for directed acyclic graphs in both ideal and not ideal conditions. And my main line of idea is to try to embed causality within machine learning, both to render it much more explainable and to make it much more efficient. Now, my research goal for the next 1 to 2 years is to optimize causal discovery, especially in very constrained situations. For instance, when the agent cannot observe everything, or when it's not in a condition to be able to act upon many things. And the idea is also to implement not only what I'm using now, which are completely transparent algorithms, but also reinforcement learning and machine learning a bit more intensely, even at the cost of transparency, in order to enhance the discovery and the efficiency of the model. My vision about HAI is this idea of having causal theory within everything that we work on, so that we have complete transparency over why the agent, for instance, artificial intelligence takes a number of decisions, and This can also, of course, have the positive repercussion of users being much more interested and trusting of the artificial intelligence process. And of course, the idea of causality would eventually enhance efficiency for the machine learning models as well. So that's something that I'm looking forward to. I leave the floor to Francesco now.
Good evening to everybody. I'm Francesco Di Corsi. I'm a PhD student at the second year at IIT. I work in the Ubiquitous Internet group. My research has a twofold effort. One is that of evaluating the maturity of decentralized online social networks through microscopic social network analysis, particularly by using a particular model, ego network model, which is the Dunbar's model. This is because they will likely leave their API open, so it is important for researchers to have an idea of the maturity of the server, of the service that is used for research. Another, my current effort, I think the greatest effort, is that of a cross-dataset text-based psychological prediction. And I'm currently studying the state of art, particularly focusing on the Big Five test, also known as five-factor model. And I'm validating the previous results through a new evaluation framework, a more refined evaluation framework. Most importantly, I aim to approximate, not strictly replicate, but approximate the state of the art, but on cross-dataset prediction, even on quite different type of data with regard to training data. So in the next year, I want to keep on observing the state of these new types of social networks by leveraging the Dunbar's model. And also, my main point is that to develop a linguistic, psychological, and sentiment-aware cognitive offloading tool. And this type of, let's say, detailed recommendation system will be made by leveraging the social aspect of the ego network, the Dunbar's model, and enriching it with both linguistic and psychological dimensions. So I'm quite dystopic for the next years about artificial intelligence, but I think that it has to be tailored on user specificities in great detail, I mean. It must be safe, transparent, accessible, and explainable, but most importantly, it has to be both scalable and sustainable. Thank you.
Good afternoon to everyone. I'm really grateful to Mattia to be in the Young Researcher Group still. My name is Andrea Beretta. I'm a cognitive psychology working in explainable AI before and now working in the VP1. And I'm a researcher at ISTI CNR. And I belong to KDD Lab. So what do you do? I'm interested in the cognitive aspects related to the user interaction with AI systems, and especially in user AI systems that explain themselves, and how we can support the complex and uncertain decision-making through this kind of system, in order to reduce the human error during this, the research of information in those kind of systems that can be decision support or even maybe just a large language model. I'm really also interested in the trust calibration and the reliance behavior on such system, and how we can improve the decision making with correct reliance behavior on the system while when we do information seeking through this kind of AI. So looking forward, my vision in 1-2 years is to support, understand and support the dynamic trust between the human and the AI system through the idea of a joint cognitive system. So an AI that can really support the user in their specific task. And my main idea is to develop a framework of interaction between the human and the AI. And thinking also about the task we can support with those kind of system that can be more than a tool and more related to an idea of an agent. But we need to understand exactly what kind of agent we need to support the user and human goals. So my vision in 1-2 years is understand the psychological process beyond the choice that we can be supported by this kind of system and make a real user-centered AI system that can really support human in their goal and in their single task. In both the individual and organizational level, in order to achieve it through the cognitive comprehension of those kind of feature, how to improve the organizational decisional performance, or what is called in decision intelligence. So the second point that has a paramount importance is to develop metrics for evaluating this kind of decision or a supported decision by AI, in particular when they are uncertain, complex, or ambiguous choices. The last point is to examine how social and organizational context can shape this kind of reliance or not reliance behavior of the user during the accomplishment of the task. We have seen many of these aspects also during those days, and the importance of human-centered AI based on human feature, on human cognitive human cognitive feature, and how we can support them in the most efficient way to really reduce the user faults and errors. Thank you.
Yeah, good afternoon. I'm Nicola Messina. I'm a TD researcher, so tempo determinato in Italian at ISTCNR as well, and actually from a different lab, so artificial intelligence for media and humanities. And what I do, pretty much a lot of things, actually too many, but the main hat is deep learning for vision and language understanding. So I like to study learning and study multimodal spaces. So for example, if you know CLIP that merges together textual and image information. I also had a talk yesterday about understanding limitations of current visual language models, and we discovered that they have many limitations, especially in the understanding of fine-grained aspects. So, for example, not only understanding that dog and cats are different things, but that white dogs and black dogs and white dogs are different as well. So also I'm interested in unsupervised and weakly supervised learning, so use few annotations, weakly labels to understand patterns of images and text as well. And I'm interested in many downstream applications. The first one that I want to mention is large-scale multimedia retrieval, for which in AIM we are developing a software that is called Visione, that is an interactive video search and browsing tool that actually competes with other interactive systems in annual competitions and is reaching very good results. And also in other tasks like open vocabulary object detection and prompt-based visual counting. And I'm working basically on WP 1.3, cross-lingual and cross-modal learning. The research goals in the next years will be probably to develop some fine-grained aware visual language models, so that try to solve the problem that I was mentioning before, so distinguishing fine-grained categories. So working on large language models, large multimodal models that are able also to process and understand also videos, and in particular long untrimmed videos, for example, for complex visual question answering tasks that would improve also, for example, interactive chat-based multimodal models. And also I'm also interested in other modalities, for example, audio that we are still never explored in deep yet. And my vision, well, it is a difficult question, but I think that with DeepSeek we have seen the burn of some large language models that can reason like very aligned with the human reasoning. And this is thanks to reinforcement learning and stuff like that. And I also think that as of now, these are only language models, but in the next months or years, this reasoning, like humans' ability, will also shift to other modalities as well. So we will not be able not only to perceive an image, but also reason deeply about it before giving an actual answer. So not only to understand that there is a dog that is a simple, let's say, matching function. So, but also to understand, for example, to solve visual reasoning problems, very complex visual reasoning problems. And I will think also that large multimodal models will become essential tools for humans. So I strictly believe that these will be interactive tools. So I have in mind content creation, multimedia industry, situations in which the user should interact with the system, in this case, for example, using natural language, and the system returns some result that then is ulteriorly refined by the user in an iterative and continuous manner. So that's all. Thank you so much.
Hello again, my name is Elio Grande. I'm a PhD student, third year, for the PhD in AI for society, but I come from philosophy. I have a master's degree, and I'll be very brief, also because I also spoken. What do? I try to study and build relational ethics of artificial intelligence. As you have seen today, I'm working on a double mirror system design, and I am working the WP 1.6 legal and ethical design of trustworthy AI systems. My research goal in, say, 1 year is the first one is to improve and test my endless tuning project together with the main experts, say doctors or other kind of experts. And well, my vision on HAI, I believe strongly that human-centered AI must be cornerstone, and that's why I have the strong desire to spread AI ethics, because I think that we have ethics, not simply computers. So if we have to say defend ourselves, the first thing is to be conscious and then to have an ethic. And I think it's okay. Thank you.
Io ci sono. Hi everyone, I am Silvia Radai. I am a RTD from the Department of Civilization and Knowledge of the University of Pisa, and I work on the work package number 1.6. And my research interests are focused on the concept of vulnerability as a baseline for human-system interactions and cooperation. And I recently published a monograph on this topic. So I try to show that vulnerability can be also a useful foundation in AI ethics, because it can be applied for human vulnerability, but also system vulnerability. And I'm investigating how these two dimensions of vulnerability can be interact. And the challenge is to find a common idea of vulnerability that is not a form of anthropomorphization. So starting from this ethical perspective, I think it's possible to rethink a framework for ethical principles, and with a specific attention with the social dimension, and to overcoming an overly individualistic approach based on the concept of autonomy. So collaborating with the TP1, I have also analyzed this concept in the AI Act, the role of this concept in the AI Act, and however, despite its low usage, it's a very important concept because it's very linked with the concept of risk. It is in particular interesting to understand the relationship between the two concepts and the more social aspect of the concept of vulnerability instead of that of the risk. For my future works, and this is also my view of this theme, my goal is to develop an idea of digital environmental ethics based on the idea of digital garden, which I think is a concept that perfectly fit to rethink human system relationship of vulnerability. And I think that in this context, the role of care is a strategic aspect. And so what I think for my vision is that starting from this perspective, we can and we should contribute to to have a redefinition of the concept of a human and to enlarge our consideration also of the social aspect that are related to AI ethics, in particular the equitable distribution of data and knowledge. So thank you, and I take the floor.
Hello, I'm Marco. Some of you may know me because I share the office with Mattia here. I'm a researcher at RTDA, the Department of Computer Science, the University of Pisa. I'm also a member of the Computational Intelligence and Machine Learning Group. This is my mail in case you want to get in touch. So what do I do? Several things. First of all, within the FAIR project, I mainly work on explainability on graph data. So we have this kind of mathematical object, which are graphs, which let us represent complex phenomena and complex data. But they also come with, let's say, complexity. So we are able to represent many things, but we also pay in terms of maybe computational efficiency. So we need to study methods that are both efficient and effective, and so we can harness the power of graphs. And also, it's good to equip models that operate on graphs with explainable capabilities so that decision makers can use both models that are powerful, but at the same time they know what's going on. My second topic is quantification, also on graph data, and quantification is a fascinating topic because you are not interested in predicting single instances, but you are interested in predicting, let's say, quantities on groups of data. You think about elections. Okay, so you have a group of voters. You are not interested in the vote of the single person. You're interested in the aggregate data. And by applying quantification on graph data, we are able to do this kind of things when data is interconnected. So, for example, on social networks. And my research has many applications. Usually, I mainly work on applications in healthcare or social network analysis. So in 1-2 years, let's say at this point we have very good models that operate on graph data, and we need to refine things, like make them computationally tractable in many ways, or being more environmental friendly, because graphs are generally large, especially those that you use in the real world, and they require many resources. So we are trying to scale this model both in the computational sense, and also we are always trying to improve their effectiveness. And also we are trying to go one step ahead and try to make these models readily applicable in safety critical domains, and this is by enhancing them with explainability techniques. And in 1 or 2 years, this is related to what my vision is for the next years, and where I think that we will have enhanced human decision making by supporting the human decisions with models that are not only effective but also robust and explainable. Thank you.
Okay. Good evening, everybody. So my name is Michele Fontanesi. I'm a third-year PhD student, and I'm currently working at the Department of Computer Science here at the University of Pisa. And as a member of the Computational Intelligence and Machine Learning group at the department, I'm carrying on research activities on explainability for graph data. And in particular, I'm trying to give my contribution to this kind of field by performing research activities, and both basic research activities and applied research activities. As for basic research activities, what I'm trying to do is to use explainability in order to characterize and distinguish different types of machine learning model for graphs, so identify what kind of differences there are between machine learning, between models that are able to take directly as input graph structured data. And as for applied research activities, what I'm trying to do is to gain new knowledge about the problems that these kind of models are able to solve in complex fields like biology and chemistry. So looking forward in the next year, basically what I'm trying to do is increasing the trustworthiness of machine learning for graph by studying their generalization capabilities, and in particular what I want to characterize is their inductive bias, so identify how these kind of models are able to perform the inductive leap, reach generalization, and what kind of pattern they can exploit from the data in order to reach these capabilities of generalizing on novel data. And the second point that I want to reach is harnessing explainable machine learning for graph to foster novel discovery in complex domains, as I said before, like in chemistry. So as for my vision, I believe that humans' analytical skills will be reinforced by a reliable and trustworthy system, and this will probably push even further the pace at which innovation is going and the research is going. So the future is looking promising, and we can contribute to it by keep doing our research. Thank you.
So, hi everyone, I'm Luigi. I'm a third-year PhD student here at the Department of Computer Science at the University of Pisa, and I'm a member too of the Computational Intelligence and Machine Learning group. I'm working mainly on task 1.3.2, which is the one related to lifelong learning on complex data. And so my main focuses are, on the one hand, on the compositionality aspect, so the ability to compose and to merge together different models in order to enforce adaptability in different scenarios and for different downstream tasks. And on the other hand, I'm working on continual learning, which is this idea and these techniques to make machine learning models adaptable to non-stationary environments, so to scenarios in which you have different tasks and different data distributions over time in input. So as for my research goal in the next future, I believe and I want to work on this enforcing adaptability of pre-trained models to different downstream tasks, which is something that nowadays is not that easy to make these large models that we have available doing different tasks over time, of course. And I also think of this continual compositionality as one way to achieve a higher efficiency of reusing the same models over time with a different composition in order to have a higher models of efficiency. As for my vision in the future of AI, I really foster for this future in which different models can be composed together, and you can have a marketplace of large pre-trained models that you can obtain and merge together and this could bring also a better and greater interaction with humans, with a conversation, almost a conversation-like relationship with humans over time. And thank you.
Good afternoon, everyone. I am Caterina Pareo. I am a researcher at RTDA at the University of Pisa in the Department of Law. Yesterday I shared my research about the role of workers' representatives in the regulation of AI, but another topic of my research is represented by the algorithmic management and risk of discrimination. I'm working on working package 4 and in particular on task 2. And more in general, I studied the impact of AI and the use of AI in the workforce management. My research goals in the next years are, first of all, the first goal is to identify the contribution that workers' representatives can and trade unions can make to the development of a human-centered AI. I would like to analyze some collective agreements about artificial intelligence, and on the other hand, about the other topic of my research, I would like to develop regulatory solutions aimed at avoiding discriminatory effects of AI. About my vision of AI in the next year, I think that the use of AI in the workplace will require transparent and explainable decision-making mechanism. And I think that the use of AI in the workplace will require human oversight. So I think that the development of this technology has to observe these principles: transparency and explainability. And I think that the human will be central in this digital transition. So I think that it will be necessary to guarantee human oversight in order to safeguard fundamental rights of workers. Thank you very much.
Hi, I'm Martina Migliani. I'm a postdoc researcher at the Department of Philology, Literature and Linguistics at the University of Pisa. What I do, my field is natural language processing and computational linguistics, so besides teaching machines to talk, I also study how human language works with the use of computer science techniques. What I do in FAIR, I study large language models' knowledge of causal relations, in particular if they can distinguish causal relation from temporals one. And I do that not only by analyzing their performances via prompting tasks, but also by analyzing their linguistic competencies through probability-based techniques with measures like perplexity. And what I do is also comparing what the results I obtain with what are the human perceptions of the causal relations. So in the future, I would like to explore also how multimodal model understand causal relations, and I would like also to use external resources to see how language models are helped by these. And also I would like to collect more human data. At the beginning of this of this project, I realized that me and my colleagues have imagined the boundary between temporality and causality in a different way compared to crowdsourcing annotators. So while we were studying machines, we discovered something more about humans. And I think that this is also because of this, the interdisciplinarity of my field. And I hope that in the future, this interdisciplinary approach will be maintained to build solutions that are with clear limits, with models that are sustainable, explainable, and made less for machines and more for humans. Thank you.
Okay, sorry, I'm not okay. Here. Yeah. Hi, I'm Helena Seino. I'm a bonus track, more or less, because I'm coming from Università Cattolica del Sacro Cuore. I'm from UMain Technology Lab. You listened the talk that yesterday Professor Riva, that is my professor, gave. And I am a postdoc there. I've just got my national AI PhD, and yeah. So what do? I work with affective computing, so that it's trying to connect physiological data and facial expression from people to and trying to put together some algorithm that try to classify what the person feel or is in that moment. But I'm also working in decision making, and especially in the Coxai cascade call that is in the work package 6, that is about trying to understand if explainable AI can actually improve and how decision making, and if we can make artificial intelligence and humans work together to get better decision. So, looking forward, which are my research goals in the few next years? I would focus on trying to assess actually how humans are in the human-artificial intelligence relationship. So, because there are a lot of works focusing on technical matters in the AI fields, but a lot of time the final user is kind of forgotten. And I would like to focus more on that aspect and on their cognitive aspect, and try to understand if for example, the suggestions that are given to the users are actually useful and actually made them do, for example, better decision. And what is my vision in 1 or 2 years? I hope that all the AI community would be more focused on the final human that it's going to use the products, also on the cognitive side, so working more in an interdisciplinary way and trying to understand the human on its own. And also, I hope that it would be in this way also feasible to get something that can adapt to the user that it has in front of, maybe because it has a different personality, or maybe because you can get their physiological data, and so you can understand if the person is anxious or not. Okay, thank you.
Okay, this is me now, it's not Elena. Hi, I'm Andrea from University of Pisa, computer science. I'm a postdoctoral researcher, and I am a member of the KDD lab. This is my contact if you need me. But what do I do? Well, I would say I don't know what I do, but I study AI systems that know what they don't know. And this is a triple, in my view, that is basically learning when to abstain from providing a decision, when to defer a decision, but also when it's more safe to inform the user that there is some uncertainty in the decision. And since my background is in economics, I also like causal inference, as I think it's a practical way of implementing things in real life. So I work, due to this, I work mainly in my research is on work package number 2.2, and most of you might have heard of my pestering emails for the use case and pilots asking you to fill reports and meeting with me. So I'm sorry for that, but that's what I have to do. And looking forward, since I am from Sarzana, I am my region is quite known for being always complaining about things, so I want also to complain here. And my research goals in 1-2 years are quite ambitious here, like what does it mean to improve human AI teams or better evaluating them, but I mean, you have to be ambitious in life. And regarding my vision, that's where I complain. And the first complaint I have is that now everybody's talking about large language models, but why do we really need large language models in several tasks? There's no need for them, and so I think that the community should start understanding that there are some tasks where you don't need large language models. That's my first populist view. Second, I think that humans, we often forget that they are quite irrational when they do things. We are lazy, we don't care about doing things, and so involving them in decision-making is sometimes wrong, and so we have to take this into account. I know this is not very shared as a view, but think about what you do in your daily life, and then maybe you are convinced by this. And then finally, I really think that what is currently going away from our research is that whenever you have garbage in, you have garbage out. And there's no way to go beyond this. And so I think that if you really want to build good AI systems, you really need good data to feed those systems, and having good data is extremely costly, and it's quite a long task that is annoying, it's time-consuming, but that's the only way I think it's possible to build better AI systems. That's it. I stop complaining. Thanks.
Okay. Hi, I'm Katerina Papagiannouli, and I am an RTDA at the University of Pisa in the mathematics department, and I'm working in the probability and statistics group, and this is my email. Okay, and what do I do? Generally, I'm trying to understand machine learning methods using mathematics, the theoretical approach. And as I explained yesterday, the first thing recently I'm very curious about is to understand the dynamics of transformers. How do they learn? Then also I'm trying to understand the dynamics of neural network architecture for generative learning in order to learn covariance learning operators. Imagine that you have a data set and then you want to learn from this data the distribution, we assume that we have Gaussian processes, which is an infinite dimensional object. So we use gradient-based methods to learn these covariance operators. Another thing that I'm doing is I'm using optimal transport, and we have again we have a target, and then we have a source, and we try to match the source with the target using optimal transport. And the spatial, we have to find this optimal entropic map, which will actually match the source with the target distribution. And recently we started working with some biologists in order to apply this method for gene expression in the cells. And finally, what I'm also very interested in is the nonlinear inverse problems. The nonlinear inverse problems are connected with PDEs, and especially when you have in tomography, when you see all these scans are connected with a PDE model, and for this PDE model you have an operator that you have to understand. So what we are doing statistics, Bayesian statistics for this, and recently we use the results that we get from Bayesian statistics in order to learn this operator, and we call it a neural operator. And okay, what I'm looking forward to is my research goals is for sure, like, first to understand better how transformers learn, because in terms of mathematics, the understanding is very limited. You have to assume a very simple model in order to understand what is happening in the training, and maybe use, like, maybe have a better understanding of how LLMs learn. And then what I would like to do is, like, with the rest of my research, to create robust algorithms using neural network models for the methods that I explained before. And of course, like, my vision generally for a human-centered AI is an interdisciplinary approach, because I believe that we have to work, like as many other researchers say, that we need to work, like, from more disciplines in order to understand better artificial intelligence and create tasks, like, which are like more fair, like transparent and trustworthy. And maybe, like, because recently it's so much about what artificial intelligence can do, that maybe make people less scary that AI will replace anytime soon, will replace them anytime soon. So singularity is not coming yet. So yes, that's all. And thank you very much. And thank you, Mattia, for the organization of this session.
Good afternoon, everyone. I think I am the last one. I am a junior researcher, RTDA, at Scuola Normale. I am working on responsible generative AI mainly, and specifically on different research lines. First, we are trying to building a perspective-aware AI system with multi-perspectivism paradigms, because researchers show that human values are pluralistic, so we need to kind of align our models with these pluralistic human values by incorporating different diverse perspectives of humans. And secondly, we are evaluating robustness of foundation models. There is this autophagy process that's a very new, like it's a very novel research direction. When the large language models or generative AI models are fine-tuned on the synthetic data, that their own synthetic data, it has been shown that it might lead to model collapse. So we are losing some model performance. You can think of it as, for instance, simply the linguistic diversity, if you think of text generation models. So we are trying to evaluate the robustness from the perspective of autophagy. And thirdly, we are working on building a responsible chatbot, generative AI chatbot in public administration. This is more like a case study. We are collaborating with Regione Toscana, and it's an ongoing case study. And in the second big umbrella, I'm also working on the human AI collaboration. We are using large language models to create explanations, but in natural language, for synergistic human AI collaboration in a chatbot settings. And the second research line is on we are trying to get explanations in critical scenarios like healthcare to support clinical decision support systems. And our specific use case, this is a case study as well. We are collaborating with Cisanello Hospital, and it's specifically on a real liver transplantation data set collected from kind of all the hospitals in Italy. And you know, like with these research lines, I'm working on the WUPI 1, 4, and 6. You know, 1 is more like the explainable AI. 4 is the impact of AI systems, specifically here foundation models on society, and the sixth is the trustworthiness. For the upcoming 2 years, my research goals are the following. I will be injecting multi-perspectivism into learning to differ environment, a paradigm, and then we are working on incorporating multi-perspectivism in in-context learning settings. So we want to apply in-context learning, prompt large language models, for instance, in order to obtain diverse perspectives. And the third one is robustness evaluation about this autophagy model collapse pipeline in diffusion-based LLMs in comparison to autoregressive based LLMs. This, the diffusion-based ones is a novel research line. So we are also curious about that difference. And also, we are investigating some methods for mitigating this model collapse, because this first part is for detecting the model collapse, and the second part for mitigating it, which is more difficult, I should say. And my vision on the upcoming years, not making AI safe, but making safe AI, like trying to, design these AI systems, safe AI systems, by constructing them from the beginning, not using this safe AI terminology as a post-processing, as nicely put by Stuart Russell in one of his recent talks. And also, lots of discussions are going on about these agentic AI applications. So I'm really curious about the safety considerations related to this agentic AI applications, how we should constrain them to make them beneficial but not to be harmed, because if we are using them like as a general purpose systems, they will be probably harmful than beneficial. So I think I'm done. This is all from my side. Thank you.
Okay, sorry for the delay, I was in class. So, my name is Fabrizio Ruffini, I'm an RTDA plus a PhD student in AI for Society. I work in the Department of Information Engineering at Pisa. What I do, I wonder how to make AI trustworthy, especially working on explainable AI, both using interpretable by design models or applying post-hoc analysis on opaque models. And the second topic is how to ensure data privacy. The paradigm I usually use in my analysis is the federated learning paradigm. And I work inside the WP 1.5. Looking forward, my idea is that we need to improve the explanation currently available, both in terms of meaningfulness and both in terms of intuitiveness. Because depending on the stakeholder, you need to express the explanation in terms that the stakeholder is able to understand. So if you cannot explain it simply, you do not understand it well enough. So in my opinion, we have to create something that is really useful by people. Also, we need to solve conflicts for different explanations, because we see in different experiments that if you apply a post-hoc method instead of another, you end up with different explanations, and this is not really reasonable for me. In some years from now, for human-centered AI, I think we need strategies to alleviate the feeling of uneasiness in using AI. For example, I reported here the case of the murder for the CEO of the United Healthcare. That was murdered because, let's say, the people don't trust algorithm, especially when they feel injustice towards their expectations. So I think we need to alleviate the feeling of uneasiness in using AI, especially for life-taking decisions. And then I think we need to create a shared taxonomy, because also in this workshop we see many different terms for the same things, and I think it's not a good practice. And also we need to start communicate the best practices outside the academic world towards the private sector. And this is all.
It's over, it's finished. Oh, thank you so much. This has been really a fantastic session, I think the most entertaining in my opinion. I would like to ask all the young researchers to come up with a photo all together. Come? We can use front
Chairs.
seats and so please.
Front seats, dai. Vai.
Don't be shy. You should fill the chairs.
No, iniziamo. Perché siamo noi che immaginiamo il finale più bello. Questa qua. Sì. Volevo solo metterci quello sopra. For once, let me pretend that I'm taller.
Vieni anche te. Siamo più giovani.
Vero? Ma ha parlato di capelli bianchi, Anna, mi sono...
For a mysterious miracle, we ended precisely in time. We were absolutely not, sure of what would happen in this session, but it was perfect. So perfect timing. We wanted to finish a few minutes before 5, and we won't take much longer, Francesco and I. Just a final reflection. And I think that this last session is a good, let's say, parabola of metaphora of what happened during the 2 days overall. They were very colorful, refreshing days where we made a deep dive in the many aspects of human-centered AI research. I think the kind of fresco that comes out of it, it's really heartwarming in my perception. Really, I want to thank very much everybody who contributed to this very lively discussion. And I think that really the young researcher session was somehow a very good summary of the many facets that we are trying to tackle in this holistic way, by taking together so many different perspectives, so many different angles on the aspect. I think we are a blossoming ecosystem, research ecosystem. Our community is actually showing an impressive advance compared to 1 year ago in terms of both methods, both foundational research and also applied research in many different use cases. I personally think that and I thank the people from Work Package 1.7 and also Andrea Pugnana, who worked hard to have the people there. But the use case session this morning has been really amazing in showing non-trivial applications of human-centered AI. I think that our community has increased not only in size, but in relation. No, it's in complexity of the network, and it's keeping somehow growing in this direction. Also the multidisciplinary fertilization, it's occurring. Of course, it takes time. And this is essentially what I want to say next. It takes time, and for the moment we are within a short project instead. No? 3 years time, 3 years landscape for such big construction, it's really outrageously little, small time frame. As of now, fair is going to end at the end of this year, and possibly there can be some limited extension, but the point is not a limited extension. The point is how to, somehow think about what can come after this, because after a successful project start, you need a sustainable way of somehow investing and reap the fruits that will come up from this ecosystem. So what will happen next? Essentially, two time frame. In the short term, of course, we will have the customary, very heavy-duty reporting that we are compelled to follow. I can tell you that Mattia, Francesco, and myself spend more time in preparing reports than in doing research. So it's really, and by cascading, many of you, the work package leaders, but all the people in this room, it's involved in a very heavy-duty project reporting. There are upcoming deadlines this week for the papers, next week for the reports, to update our key performance indicators, which, by the way, are looking better and better. So please keep on doing that, because it's an important part of not only doing good, but showing that we are doing good also with numbers. But then there's, by the way, we will have the review meeting with the external reviewers on April 30. This has been fixed. So this workshop has a very good timing, and the reporting next week also. So it will give us the chance to prepare a robust, successful project review meeting with the external reviewers on April 30. And it will be a short meeting, so probably it won't be possible that all the work package will report about all this amount of work, but we will try to find out what they want to hear from us and how to organize ourselves. It will be 2 hours total, so it must be well designed to convey the right message. But of course, it's a strategic view. The strategic view is what we can do as a community of researchers and the scientific technical board, and the foundation, the FAIR Foundation, can do to ensure longer-term sustainability to this huge effort that is being done in this 2 years now. It will be 3 years in a year from now. So the question is how to convince the ministry, the government, to continue funding this this project, because it's needed, because it's important, because it is doing good stuff. And this is the final message. I think that the fact that we are a very healthily growing ecosystem, it's very important from this point of view. We need to stress the fact that it's by creating such ecosystem that we can have an impact on scientific research, but also on innovation and societal and industrial innovation. But this view should also coexist with some champion concrete results that we can showcase as early results of this ecosystem, so that we can somehow show that we are excellent, not only because we have already published more than double the paper that we promised to publish, which is of course an interesting thing. It's important, but it's not enough. I think that something that we will need to do is to select a small number of key concrete demonstrators of our early research output, so that we can be more effective in pushing this idea of continuing after the the formal end of the project. I don't know if you want to add something on this.
If it's two things about what you really are telling about this big community that in some way FAIR created. Today I was talking with one of the colleagues who was present here, and he told me that he was developing really a system with other colleagues, but these colleagues were really known inside the FAIR community. So this is, I think, is a very good way just to understand that FAIR contribute really to create this community in also the collaboration between researchers with the aim just to create not only new research but new system and new possibilities also for bringing this system outside. The other consideration in a period in which we have a number of cut-off in the balance of the university, you told that we really created a very large community, and I want to wish all of you that really we didn't achieve the peak of this community, but we can really growing also in the future in numbers, because really we had this opportunity with this funding from FAIR. FAIR contribute in any case to create a number of positions, but we have to hope that this trend we will not terminate with the end of FAIR, but will continue in the future. This actually is my wish, but I think it's the wish of everyone here. Okay, thank you.
So there's not much that keep us away from a well-deserved Prosecco, but I really would like very much to say thanks. Thank you. Of course, to Francesco that helped me shaping up the program, but well, the guy that worked hardest is Mattia Setsu, that I would like to really... Thanks, Mattia, for your work. There is also the very precious work of the people behind the curtains there, Vittorio Romano and Daniele Fadda, who managed to... And also behind the scenes in the administration department, the persons that made all this possible, that paid for our food and make all these things somehow to work and be financially sustainable, Camilla Sovani and Stefania Pasqualetti. Thanks to the work package leaders. They're doing an amazing job. Thanks to the many presenters of this workshop. I think it was very tiresome, but also very powerful 2 days. So really, thank you very much for making all this possible. Thank you.
And of course, we have to thank Dino, because really he has the soul of this first ecosystem. Okay, thank you.